Good afternoon, good evening, good morning to everyone, depending where you are. Good evening if you are in Asia, good afternoon if you are in Africa and Europe, and good morning if you are in America today. So welcome to our webinar about what's future for HVAC sector 2021. I leave the word to my colleague Silvia Romano for the introduction. Silvia, the floor is yours.
Thank you so much. Thanks for the introduction and my big regards and warm welcome to all our audience. Thank you, of course, for being with us. And I will give you a very short guide how this webinar works. As you can see in the slide, it will last about 3 hours, starting now until 4:35 p.m. It will feature 10 presentations from leading companies worldwide among our platinum partners. And you have this great chance to get in touch with them, to hear from them. And therefore, please make your questions anytime. You can write them in the box on your right, in the question box. And we will read them to each presentation after each presentation. Plus, we will have a few short debates. So your questions and your feedbacks are very important to us. If the speakers do not make it on time to reply to all the questions today, we will forward them via email. So your questions will be for sure satisfied. And you can view the webinar once again. You will receive the recording afterwards. If we can go to the next slide. Okay, so here you see the agenda that you have received via email and you've seen on social medias. As we said before, we will have 10 great presentations featured among our platinum partners of Centro Studi Galileo. We will start with Ms. Solana from Carel. Then we will have Mr. Pisano from Dorin, Mr. Mastravasco from EPTA, Mr. Revello from Cremurs, Mr. Fedeli from General Gas, Mr. Mozzato from Vegan, Mr. Harris from Philpees, Mr. Lucchetti from Rivacol, and Mr. Sepe from Castle. So
hello, everyone.
Now I would leave the word after the few next slides. Thank you. So as we were saying before, we thank all our partners, and these few today are among our platinum partners, which we thank for the long-standing and tight cooperation, which allows our audience and our students to profit from their exclusive contents, which they share with us, of course, at conferences and seminars, but this year through webinars like these ones. And last but not least, I would like to mention to all of you one of our upcoming international training sessions, which will be on the 3rd of February. So if you wish to participate, it is the first and so far only certification available for sanitation and disinfection of HVAC and R systems, which is also a topic that we're going to face today. So if you wish to participate and get your own certification, please do get in touch with me, and I will be pleased to enroll you in our next session. So after this very short introduction, I am pleased to give the word to Area President, Mr. Boni. Thank you all.
So, thank you so much, Silvia. Thank you to our participants of today, our speakers. We can read it again. Thank you to Michael Harris, Philpees. Hello, Michael. Hello, Filippo from Rivacol. Hello, Miriam. Hello, Antonio. Ernesto from Cremurs. Rodolfo from Luve. And Sergio from Vigam. I can see you all. And Stefano from General Gas. And also the others. So they will speak in few moments. I will speak first. So allow me to have 10 minutes of speech. You can turn your camera off if you want. You can turn your Microsoft off. And I see you in just a sec, okay? So thank you so much, everyone, being here today. We are around 100 participants at the moment. Nearly, yes, 91 participants at the moment. So we are very happy to have you here today. And today I would like to talk to you about 2021, what's the future for our sector. I am the president of AREA. AREA is the European Association of Associations, from 26 associations of contractors from all Europe, from 22 European countries and 3 extra European countries. We can say 4 now because also Great Britain will be in extra EU in few days. So also from Norway, Turkey, and even Thailand. And we have from Germany, from Austria, from UK, from France, Spain, members. We have the voice of technicians, the people that install, maintain, repair all kinds of systems with any refrigerants inside this system. We have a board every association. I'm the president. Then we have a newly elected vice president from the Netherlands, a treasurer from Ireland, then from Greece, Finland, and Poland. And we are divided in working groups, working in different topics, which are very important at the moment. For example, we have a working group refrigerant, working group sustainable innovation, working group human capital about training and certification, and the working group about legislation, which is very important as well. We do guides for our contractors, our technicians, to help them in this sector, which is a very dynamic sector, very moving sector, new technologies, new legislation, new knowledge, new competencies. In the left of your screen, you can see an app, the AREA app. In particular, this one is about the EN378 app to select the right system with the right refrigerant and the right charge. And all our guides are translated in nearly 16 languages, the European languages. So you can see that we have a lot of members, a lot of work, and we can work in Europe with different countries, but not only in Europe. We work globally with other associations. I would like to tell you a few words about the importance of our sector today, but even tomorrow is important for our sector. We know that today is very important because 1/3 of all the energy used in buildings, you can see in the graph on the left, are used for heating, ventilation, and air conditioning. 35% of the energy in buildings is used by our sector. And globally, we are going to see an increase of use of our air conditioning system, heat pumps, but even refrigeration. We can see from the International Energy Agency that our sector is growing as importance. We saw this growing, increasing sharply in the last decade, we can say. We have healthier countries, China, India, South Asia, Southeast Asia, Middle East, Africa, South America, and emerging middle class in developing countries asking for air conditioning, asking for a better cold chain in Africa in particular. Environmental and energy issues. We saw climate change issues rising, Montreal Protocol, Kigali amendments rising, the F-gas regulation, of course, environmental F-gas regulation that gave us more work, but also a better sector and a better market. The heat pumps are growing constantly. The global warming is a paradox, but the global warming is getting our appliances even more needed because we have hotter climate, so we need more air conditioning, more refrigeration. And in 2021, we saw even an increase of importance. And also our sector has been under the lights of the media for many reasons. We can say for the cold chain, for supply food to our homes while we were in pandemic, we are in pandemic, we were in lockdown. And so all the cold chain from the production to the, we can say, of the starving, to the production, to the house, to the transport, arriving to our homes. Then our ventilation, our air circulation, fresh air, heat recovery. We saw that the circulation of air has been increasingly important to dilute the air for the virus because we want to have less air and less. We want to make dilution of the air to have less virus concentration. And even in Germany, for example, has been a law in the law to say we need more recirculation of air, opening window, but of course not only. We want our sector, our fresh air systems to give a help. Now, very recently, we saw the importance of cold chain for the supply of vaccines. We saw in UK, the first country to start. We saw ultra low temperature freezers needed for the Pfizer vaccine, but even for the Moderna vaccines, for other vaccines, there is needed storage, and our sector is important. And last but not least, we are going to see in 2021 an increased need of course, storage for vaccines, but also an increase speak about consultation for F-gas regulation, the review of gas regulation. And I want to say a few words about that now to you. A few words about the process and our involvement. AREA, Air Conditioning Refrigeration Association, involvement in the consultation and where we want to go. So we started in 2020, so this year, we started with the consultation, and we sent our feedbacks, our comments to what is the F-gas regulation till now. And the public consultation has been published by European Commission. The public roadmap assessment has been published, and now it's starting, and it's going to finish at the end of December, the public consultation and the target interviews. We are going to see in 2021 stakeholder workshop for the presentation of the preliminary findings by European Commission, and also an impact assessment, which will conclude this summer. A proposal for a revision in 2021. Hopefully, in 2022, 2023, after the ordinary legislative procedure, so the European Parliament, the Council of Europe will decide if we want to change anything, we will see a new F-gas revision. What we are going to see in the F-gas revision? We are going to see different things. For example, we want to evaluate, of course, the regulation till now and see what we can do better in the regulation we have now. But there is some points that we need to align. For example, alignment with the Protocol of Montreal, the Kigali Amendments, which is a global phase down of HFCs, of fluorinated gases. So we should be aligned with that one. Then we want further reduction in the sector not covered. This is what the European Commission said. The implementation and enforcement issues, illegal trade, and trading with alternative refrigerant. In particular, going deeply and more in depth in what we are going to see, we are going to see 3 points in particular: training, certification, competence. We want, as area, we commented, and we want, and we have, European Commission received 75 feedbacks from contributors, other policymakers, other associations, industry, which are publicly available on the European Commission website. And what area wants? We want, of course, competence, training and certification. Today we are going to see that from mainly all of you. Today we are here for that reason, because we want competence, we want to spread the word. So we want mandatory certification. We want Brexit to be more aligned. We want mutual recognition, harmonized approach with the restriction, tackle illegal trade, which is something very important for all of us. Enlarging the scope, which should be including also alternative refrigerant. And then also we would like to include TEWI more, so the total equivalent warming impact, but also maritime sector, shipping. I'm going quicker because I'm a bit late, but we think the gas regulation and certification is working. We think that what we have now is working at the moment fine. It's not perfect, of course, but is as good point for our sector. Okay, we have less leaks, we have more competence, we have better equipped trained technicians and companies, we have better calibration of system, measuring device, recovery use reclaim refrigerants is quite available. Okay, could be better, of course, but we have a start. And also lower quantity of high GWP refrigerants and higher quantities of alternative refrigerant. And this means that we need better competence that normally we suggest to achieve with our real alternative project. Also, European Commission came out with another report, which I want to show you briefly, about the split air conditioning, which says that split air conditioning avoiding F-gases is possible and is suggested to use propane unless prohibited by national legislation. Of course, we need, if we want that, to have better competence again. Also, from this report, we have a larger split system moving from 410A to R32 in the next few years. And also, the small system now contain R32 mostly. So it's a good achievement. In 2019, F-gas contained in split system represented 74% of all F-gas imported. So it's very important to see split system sector and look to this sector in particular. Let's go to one important topic, which is training. We've been working for training and certification deeply, globally, internationally with the United Nations, UNEP, UNIDO, UNDP as area. For example, yesterday we had a training and certification consultation forum with Qatar, for example, just to give you an example. We did the same with Kuwait, Bahrain, but other countries in the globe, just to tell you that Europe is leading and want to lead in training and certification and be an example. Also, is area we do webinars, as this one, of course, and you can see all the webinars in area YouTube channel. And you can see on your screen the real alternatives area webinar we did in Cilventa last November, October. Also, stay tuned with us with our social media. Also, we have a conference in June, which is the 10-11 of June, and I will publish this magazine, which has been issued at the European and the International MOP conference, Protocol of Montreal conference in Rome last year. And this is a magazine from the most important association with inputs from some of you as well. So I invite you to have a look to this magazine about sustainable cooling for a healthy future. We started already last year talking about healthy future with sustainable cooling. But what we want to do today is to speak about the importance of our cooling sector, and we want to restart. 2020 has not been the best year for the sector, but for the population, for everyone. We want to restart. We want to restart our sector and our market. We want to restart strong and steady. We want to restart in 2021, and we can give our role with the vaccines. The vaccines can be a starting point for all of us, and we want to start with our sector to give a help, to give a good hand, and we want to start where we were, with a healthy sector, with a healthy and important industry. So, thank you very much, and I pass the word to Miriam, and Miriam is going to talk about F-gas review. What changes will it bring? Thank you, Miriam.
Okay, hello to everybody. Thank you to Centro Studi Galileo for inviting Karel today. My name is Miriam Solana, and I work in the Knowledge Center of Karel. My presentation is about the F-gas review that is now in the consultation period. The first question is, what has been achieved so far? Here I show a graph that shows the consumption of HVAC refrigerants from the year 2007 in million tons of CO2 equivalents. The line that you see above is the baseline according to the Kigali Amendment to Montreal Protocol, and is calculated as the average between the period of 2011 and 2013, plus 15% of the baseline of the HCFC in the year 1989. In the year 2019, we start with the 90% with respect to the baseline. And as you can see here, there are good results, because in the 2019, we are well below the baseline of the Kigali Amendment to Montreal Protocol. And the consumption of HFC has decreased to 22% with respect to 2018. We also know that the emissions of greenhouse gases are decreasing since 2014. So these are good results that encourage all the stakeholders to follow in these directions. There are, of course, things to improve. Everybody knows the problem of illegal refrigerants that are entering as imports in Europe. The estimations say that this quantity, for example, in 2018 were more than 100 million tons of CO2 equivalents. And this means to emit more than 30 million tons of CO2 equivalents. So these are very huge numbers. Then it's a problem that have to be solved. The European Commission is aware of this, and indeed the fight against illegal imports of refrigerants is one of the priorities for the European Anti-Fraud Office. And the question now is, this will be reflected in the FGAS regulation, or how they will intensify the custom controls to avoid the entrance of illegal refrigerants. We cannot forget also the barriers in the transition to low GWP refrigerants, because most of low WP refrigerants are flammable, and this means that safety standards must be respected. The problem that stakeholders have complained about is that standards are different in different territories, and this makes it difficult to adapt the products to the different standards. For example, for manufacturers that that sell products in different areas, having different standard means to adapt the products to the different standard, and also in some cases to follow different trends that come from the ease or difficulty to follow that standard. So the harmonization between safety standards is one of the requests of many stakeholders, and even if the FGAS Commission, European Commission, is not directly involved in this issue, stakeholders expect that they can do something to go in the direction of harmonize the standard and have the same ones in all the territories. We can talk also about the positive things. Not all are barriers and problems. One of the strengths is the technology these days is developing very fast and in a very efficiency way. One example is the refrigeration sector that if you think in the last 5 years, for example, the systems with CO2 have evolved very fast, and they have allowed to bring technologies with CO2 refrigerant even for the warming climates, with the use of technologies such as ejector. When the technology evolves, there is new concepts to be learned, new ways to work, and so the spread of knowledge become even more important. So another one of the requests from the stakeholders is to have mandatory training on natural refrigerants and technology to face the difficulties of the use of these refrigerants. We cannot forget the global objectives in Europe. On the one hand, European Green Deal, the objective is not to have emission of greenhouse gases by 2050. In the last days, they have fixed the objective for 2030 to 55% with respect to the emission of 1990. So this is a very ambitious objective, and FGAS should be in line with these objectives. On the other hand, the European Commission ratified Kigali Amendment more than 2 years ago, and the FGAS regulation should be in line with Kigali Amendment. We know that FGAS regulation, as you can see in the blue line, is more restrictive than Kigali Amendment to Montreal Protocol, but the last step finished in 2030 and finished at a higher level than what is requested by the Kigali Amendment in the following years. So it is expected that FGAS regulation in the new version will dictate the further steps after 2030. So the coordination with European Union actions is not a question, it's a fact that must be respected, and that will guide the revision of the F-gas. If we look now at the current requirement of F-gas regulation, we can find some clues to see what can be changed from the current regulation. There are 4 applications that have a GWP limit of 150, and so it is expected that this limit will remain like that, because in this application, refrigerants with very, very low GWP limit are being used now. But there are 2 applications that have a GWP limit quite high. One is stationary refrigeration equipment that has a limit of 2,500. And the question is if this limit will be decreased to promote the refrigerants with a lower GWP limit. The other application is single splitter conditioning systems. This is one of the big questions of the F-gas, if the GWP limit will be further decreased. It's one of the big questions because in this application, the refrigerant that has been used so far is R410A, and in the last year, this is being replaced by refrigerants with a GWP between 400 and 700. So lowering this limit more would mean to change again to other refrigerants, and one of the only options would be hydrocarbons. The other question, and also a big question, is if there will be a GWP limit for stationary air conditioning equipment. We know that heat pumps are included here, and having a GWP limit would be to promote refrigerants with low GWP, and we know that the use of heat pumps cannot be stopped because they are the alternative to fossil fuels that are causing the CO2 emissions as well. The other part of F-gas regulation is the leak checking, that the frequency depends on the quantity of refrigerant, the GWP of the refrigerant, and the presence of leak detection system. So another question is if the use of this leak detection and monitoring system will be strengthened. That would mean to avoid a lot of direct CO2 emission due to the leaks of the refrigerants. The third part of the regulation is the quota system. We have seen together with Kigali Amendment GRAD before this one. So as I said before, there may be further steps after 2030. And also some stakeholders have asked to put measure for the additional recovery, recycling, and reclaiming of refrigerants that are helping to respect the quota system. Lastly, we have to look at the general scope of F-gas regulation. The objective is to protect the environment by reducing the emission of fluorinated greenhouse gases. This means that we cannot forget the indirect emissions due to the power consumption of the systems. And so some stakeholders have asked to consider the system energy efficiency that could be achieved by coordination with other European Union actions, such as the ECODESIGN directive. So this is the points. These are the open questions that can become the guide for the new regulation, and we will have to wait until the end of 2021 in the ideal baseline to see which are the concrete points that they will indicate. So this is all from my side. Thank you for your attention.
Thank you, Miriam and Karel, for always being with us in our conferences, in our training, and being so sensitive to knowledge exchange and awareness. So we have a 130 person connected. So hello everybody, and we have some questions, right, Silvia, for Miriam?
Sure. So to be on time, let me start with the first question, and then we see if we go forward now or maybe later. So Philip is asking, how will the Brexit affect on the quotas of European stakeholders?
Okay. So far in UK, they are in the quota system. They have to respect the F-gas, and they are deciding now what they will do. But in the European Union, everything will be the same.
Yes, yes. Yesterday was a webinar I participated in which they say the same, and the quotas will just split. UK will be its own quotas and divided by Europe from 1st of January 2021. Sorry. Okay. Any other question from the audience for Miriam? Please put your
Not for the moment, but we invite everybody to please make your questions, and we kindly ask Miriam if she can stay around for the next half hour, because we would like, if possible, to have few short debates throughout the webinar. I see a hand risen, but I don't get the question, so perhaps it will come later.
Okay, thank you very much.
The hand is from Laura Beron, so perhaps she wants to say hi, because 3 years ago we were in Argentina for our seminar.
Hello, Laura.
With Miriam and other partners that are with us today. So hello, Laura.
Okay, very good. So we can go to the next speaker, who is Giacomo Pisano. If you speak about ultra low temperature refrigerators for COVID-19 vaccines, cold chain, system and compressor solution. Thank you so much, Giacomo, for being with us, and Dorin for being with us.
Thank you very much. Thank you very much for this invitation. So today I will talk to you about a very actual topic which concerns our daily life and safety. Basically, I will talk about ultra low temperature refrigerators for this COVID vaccine cold chain. This is the summary. So first, an introduction to Dorin, a little introduction to the worldwide situation might be interesting to do. And then I will describe briefly system and compressor solutions which are needed, and then some conclusions. About Dorin, Dorin is a family-owned business with about 200 employees, 4 production sites in the world, 5 sales offices. We manufacture about 70,000 compressors per year. And we have a turnover of approximately 55 million euro in this is 2019, and we are actually going to grow in this 2020, even being this year very challenging. About the actual worldwide situation, nothing new. Actually, this COVID-19 pandemic has severely hit worldwide. Finally, some first vaccines are being approved. Vaccines campaigns are really challenging for every country, every government, and every authority. Vaccines campaigns has started in some countries. They are under evaluation and finalization in many others. We have some front runners. Specifically, one front runner is based on messenger RNA. How does it work? It's working different from the other vaccines we are used to. Basically, with these vaccines, our cells or the patient cells are turned into factories that are building a single specific COVID-19 protein. Obviously, this single protein cannot develop into illness, cannot develop into the virus. Obviously, this protein is kicking off an immune defense process, and therefore the immunized patients will be able to fight the virus in the future. This technology can be developed much faster, but these mRNA molecules are easily destroyable from the enzymes which are in the atmosphere. Basically, the pharmaceutical factories are modifying the structure of the vaccine to a more stable configuration. They are building basically lipid nanoparticles coating like the M&M. We know very well how the M&M candies are built. You have sugar around chocolate so that chocolate cannot melt. This is what they think about. However, it is still not enough. And vaccines have to be deep frozen to slow down these chemical reactions, which are going to waste the vaccine itself. So which are the temperature levels for this, for slowing down these chemical reactions? You have several temperature levels. You have -80°C for blast freezing the vaccine's shots. You have -70°C for stocking this vaccine for prolonged amount of time. And then you have the easier part, let's say so, with -50°C stocking, which is okay for shorter stints, for shorter period of time, for weeks. And this is nicknamed pizza box. Why? It's clear from this picture. So basically, this is how vaccines are going to be stocked for weeks amount of time for shorter stints. Basically, for this for this higher temperature, -50, pelletized dry ice has been taken into consideration, but for -70°C down to -80°C, you will require vapor compression cycles. How does it work? Basically, with -70°C and -80°C, you are working in ultra low temperature application. This system feature obviously extra low operating pressure. Very often this is well below 1 bar gauge, which means that eventual leakages are immediately turned into system contamination, and therefore this is a danger for the safety of the vaccine. And also, from a compressor standpoint, this is leading to very rapid pressure ratios increase. So again, compressors have to be robust enough to tolerate these challenges. How to do that? There are various ways. Let me cover the principal one. You can do this with single refrigerant units with 2-stage compressors, working with 404A, with 452A, and the system basically looks like that, where you have a single compressor which is split into 2 separate stages of compression, and you are doing a throttling after the condenser to basically intercool the discharge of the first stage. This system is quite easy to do. This is how it would look like in a -70°C evaporating temperature cycle, working with 452A and 40°C condensing temperature. This is actually an output from Dorine selection software, which you can download for free. It is a very user-friendly tool to size compressors and to size complete system. You can immediately see that the COP level you can expect is not very high, but obviously at these ultra low temperature levels, it is quite hard to have strong and important and big COP levels. Actually, what is important to mention is that you may reach also lower temperature, lower than -70. You may need to go to -75, -80, and then it might be good to think about cascade units done with single compressors. So basically what you will have is two separate circuits, one bottom cycle and one top cycle, working with different kind of refrigerant. Typically, the low temperature working with R23, R5008B. You can think about using R170 or nitrous oxide. This is a little bit further in development. This still needs to be validated, let's say. And in the top cycle, you may use more standard refrigerant. But this will look like a very simple cascade system where compressors are single stage compressor for each stage of equipment. This is how it looks like, always using our software tools. This is a simulation with R23 working at -75°C evap temperature and -20 condensing, with the top cycle working with 452A, -25 evap and 40 condensing. And this is delivering 9 kilowatt capacity at -75, so pretty large capacity. Sorry, that's the R23, that's the one, 5 kilowatt, with a COP of 0.53. So COP is slightly improving, but still not a big number. But again, we are thinking about -75°C evaporating temperature. So very challenging application. I made a simulation also at -85°C evaporating temperature. For a 6 kilowatt unit, the COP will further drop down to 0.4, but still you will get enough capacity, like 6 kilowatt in this case, at -85°C evaporating temperature. From a compressor standpoint, actually compressors are the only moving part in a system, so they are the most challenged component in a system. This is how it looks like. This is a picture of our two-stage compressor for HFC application. And as you can see, we have a very clean, a very lean design with no external piping. The gas is flowing fully internally into the compressor, boosting definitely the COP levels and the performance. Then you have also much less junction, which means less risk of leakages. And therefore, this design is really helping for a very safe system operation and vaccines preservation, because there will be this compressor will be subject to a much lower leakage rate. When it comes to compressor availability, this is what we can offer in terms of two-stage compressor. We have a very big amount of machines available, and I would like to mention that competition more or less stops here. While Dorin Range is able to offer a much bigger array of compressors, which means much bigger storage duties, which can be needed in many distribution centers, which can be used for stocking those vaccines for a prolonged period of time. This is just an example. With our two-stage compressor range, you can have capacities available from 1.7 kilowatt up to 7 kilowatt at -70°C evaporating temperature and 40°C condensing temperature. Basically, this one slide is showing our product range, which is bigger than competitor and is helping to deliver bigger capacities for bigger storages. We also have a bigger envelope available, which means you have more robustness and much more safety margin available for this kind of very tough applications. And when it comes to cascade system, we have a full array of products suitable for R23 with capacities from 1 kilowatt to 65 kilowatt at -75°C evaporating temperature. So just to summarize, We are facing a very big challenge worldwide. There are some vaccines coming up, and some of them will have to be deep frozen. You have several temperature levels which are required, and you have several system solutions which are able to cope with these requirements. And definitely Dorin is offering the most comprehensive portfolio for both solution I described, so both two-stage and cascade system. And we are absolutely open to offer technical support to any stakeholder which is approaching this technology. Thank you very much, and I'm sorry if I lost my connection for a moment, and I'm here for any questions.
Thank you, Giacomo. Sorry for that as well to our audience. We have 146 participants at the moment. I think, Silvia, we have one question, right?
Yes, exactly. It is from Dario, actually. And he's asking, do you expect an increase in sales of compressor for ultra-low temperatures in 2021 due to the vaccines distribution?
Well, let's say that several refrigeration companies has been inquired for compressors availability, and obviously we said yes, we have the product for you. We are field testing our compressor for several OEMs, and the situation looks promising. Now, I hope this will turn into real numbers, but obviously we cannot know now.
Of course, but your prediction anyway is good.
Yes,
So,
for my compressor, reliability and performance is very good.
Another question for you, Giacomo. Are your compressors also good for ethane and propane? Because I know that many manufacturers are looking also on ethane and propane for very ultra low temperature.
For propane, yes, our compressors are qualified. For ethane, they are not yet approved.
Okay. I know that normally are a smaller system at the moment for
correct,
for ethane and propane at the moment. So I think we have another question. Silvia, do you want to put this question to Giacomo?
Sure. So Stephanie is asking, what alternative to R23 do you test?
Well, it's a good question, actually, because R23 is a very high GWP refrigerant. This question should be turned to the refrigerant manufacturer, actually. We don't know what they are developing for this low temperature applications.
Okay.
Then we shall make
Giacomo,
perhaps the question later on.
We have another question, but I think we have to do it later because we have Francesco, which is here. I can hear Francesco. I heard earlier. Let's try again, Francesco, if you are here with us. Francesco Mattapasqua from EPTA. Let's have a try.
It is to you to start my audio now. Can you hear me?
Yes, I can see you perfectly.
Oh, excellent. Excellent, excellent. I want to thank you very much for your invitation and for always organizing these super interesting webinars. Thanks to Centro Studi Galileo is doing a great job in information and as well as in training. So I will start sharing my presentation if you agree.
Yes, please. Please, okay. We see your screen. Put your presentation. Yeah, we see your presentation and we see you it the full screen. So everything is perfect. So Francesco Mattapasqua of EPTA is going to speak about an important topic, which is Green Deal and commercial refrigeration, the way to carbon neutrality, about energy. Energy is very important, right, Francesco?
Yes, it is central. Thank you, Marco, for your introduction, and thank you all, Centro Studi Galileo. I will introduce the European Green Deal, first of all, because there's a number of actions and regulations which are around the European Green Deal. What is the European Green Deal? We know that energy is so important. Artificial cooling is the backbone of our society right now, but we know that cooling is very, very much energy intense. So we need to be very careful and responsible and choosing the right technologies and the right refrigerants to minimize, to cut the greenhouse gas emissions, especially now because the problem of climate warming is appearing to be very, 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 very important these days. We know that Europe is leading the way for technologies able to fight climate change. We're ahead on technologies, and we've set a very important goal, which is to become climate neutral by 2050. This is the European Green Deal. I'm going to show you very shortly and quickly how our industry, the commercial refrigeration, can contribute to this important goal. First of all, by minimizing, cutting the energy consumption of our appliances. So we have introduced, and we are introducing right now, new regulations and new standards that reduce the energy consumption of our appliances. And the first regulation, the most important, that is going to be applied starting from March 2021, so we're talking about 2 months from now, is ECODESIGN and energy labeling, which will concern the products that we have on the screen right now. So commercial refrigeration cabinets, any type, self-contained units, plug-ins, remotes, blinds, semi-integral, and so on, and vending machines. These are the products which will be affected by ECODESIGN and energy labeling starting from March next year. Very important regulation. The whole industry is trying to, of course, adapt its product portfolio to be performant and to be compliant with these regulations. What is ECODESIGN? ECODESIGN is a regulation that sets minimum energy efficiency requirements for our products. It means it sets limits for the efficiency and for the energy consumption of our products. Beyond these limits, you can't sell the product. The product is prohibited in the European market. So of course, indeed, this regulation boosts the innovation and boosts the competitivity among companies. And we are, of course, going to apply this regulation very strictly in Europe, so that only the best products will be able to circulate in the European market. The second is the energy labeling, so setting energy efficiency classes for our products, which is a new thing for commercial refrigeration appliances. It's going to come at the same time, March next year. You can see the ECODESIGN limits that are going to be applied, as I said, in 2 months from now, and you can see the energy classes and the definition of the classes, which will be enforced starting from next year. So all of our products, commercial refrigeration cabinets, will have an energy label showing the energy class and the performance in terms of energy consumption of our products. This is very important. This is a very important process. These are the labels. We have, depending on the product type, we're going to have 3 kinds of labels. One is general for display cabinets, one for beverage coolers, and one for ice cream freezers. The energy labels will be new starting from next year. We will have new energy labels in place. And you're going to see that they are very clear, very direct. They immediately give you the performance of the product, its energy consumption. And they have this kind of QR code you can see on the top right part of the label. The QR code is very important because looking at the QR code with your mobile phone or portable device, you are immediately connected to the European database, which contains a lot of information about the products. EPREL is the database, is the European Product Registry for Energy Labeling. All of the products circulating in the European market are transferred, are stored in the European database, which is used not only to contain, of course, the information about all of the products that circulate in the market, but it will be mostly used by our clients to compare products. So we have, for the first time, a real global aggregate view of what is available in the market, and our customers, our clients, the consumer, will be able to compare products before they buy. The comparison will be very easy. Anyone can connect to EPREL and download any sort of information about the product he wants to buy, and he can make a very wise decision afterwards. And of course, this is going to be at the same time the registration of our products is going to be in March next year when the new regulations will be applied, and every manufacturer will have to register its product in the database before he is allowed to sell it in the European market. So very important for us to allow and a very effective implementation of the regulations. Eurovent associations been very active, and we've worked also. I did work personally in the product group which was responsible to develop and to put together a very important document for our industry, which is the Eurovent industry recommendation about eco-design and energy leveling. It is a document that supplies a kind of interpretation by the industry. The industry declares what is the best way to adapt, to declare to label their products and to apply the new regulations in place. This is a very important document. It will be the guideline for the industry for the good application of energy labeling and eco-design for the best benefit for the market. One important fact that is also in the regulation eco-design is the concept of circular economy. We've heard a lot talking about circular economy in the past, but now for the first time this is introduced in the European regulation. So circular economy must be applied by law. What is the circular economy concept? The concept is that we have to completely reverse the concept of take, use, and dispose. Everybody of you is used to come to a dealer and say, my mobile is broken. The dealer says, okay, I'll offer you a discount to buy a new one, and we throw your mobile phone away. And we don't want to repair, we want to replace. We want to replace, to keep the consumption of products high. This is exactly the contrary of what the European Commission and Europe wants to do in the future. Wherever we can avoid to produce, we have to avoid to produce. Why? Because producing unnecessarily means creating greenhouse gas emissions, which are unnecessary. So we have to avoid producing anything that we can avoid. If we can prolong the life of our products at virtually forever, we are cutting greenhouse gas emissions. And this is what we have to do. So materials and products must remain within the economic cycle as long as possible. This is the circular economy concept. And this has a very important impact on our field and our sector, because this is the translation is that our products needs to be working ideally for the longest possible time. It means that spare parts management, the design of new products, the information we have to supply to our clients needs to be the best, allowing the client to use our products virtually forever. Having said what I said on refrigeration appliances, let's look a little bit closer to systems. We have the F-gas regulation in place, and you can see that the F-gas regulation is very important, but the greenhouse gas emissions from HFCs are growing. And we have a scenario where they will be out of control very quickly. And in 2050, we have no chance to be climate neutral unless we turn the page. And as an industry, we are applying the refrigeration systems using ultra-low GWP refrigerants. The industry has developed CO2 systems, which CO2 has a GWP 1, the minimum of all, is not flammable, is not toxic, and is very, very efficient, and is widely used in Europe. And we're using a lot propane for our self-contained products. Both of them are natural refrigerants, and they have the lowest GWP possible. We've introduced already years ago as EPTA the full transcritical efficiency CO2 system technology, a very simple solution to use CO2 in any climate and in any place in the world. It's very, very simple. This is the key feature of this technology. I'll very close look very quickly give you a view on how it is working. The full transcritical efficiency solution is a system solution. You can see the refrigeration circuit, and you immediately notice that there is an extra component here, which is the low pressure receiver. What it is for? With medium temperature cabinets, we are running on zero superheat, the best efficiency, flooded evaporators. So we need this low pressure receiver to collect the liquid out of the medium temperature cabinets and run full flooded evaporation mode all year round, achieving the best possible energy efficiency from our system, independently from the external ambient temperature, independent from where we are. It works all year round and in any place of the world, but most of all, it is extremely simple. And the second solution we've introduced is ETE, Extreme Temperature Efficiency CO2 technology, which complements FTE in especially warm climates. So Mediterranean, Middle East, Australia, Southeast Asia, and so on, where we need the best from our CO2 system. But of course, we have to manage the problem of the warm ambient temperature. And how do we do this? We've introduced a full natural CO2 mechanical subcooler, which takes a portion of the refrigerant out of the gas cooler, subcools it, and by doing this, practically eliminates the flash gas from the system. So the source of inefficiency from the system is eliminated by this mechanical subcooler. Another simple solution, another purely natural solution that is available and that allows the CO2 system to work any place worldwide without losing a single kilowatt of cooling capacity, and always in super minimum energy efficiency, in super minimum energy consumption mode. This is the response of the industry to the challenge of the greenhouse gas emission cut and the European Green Deal. I will thank you very much for your attention, and of course, as always, I'm available for your questions.
Thank you very much, Francesco, for being on time. We have 146 persons listening to us. We have one question from Jean-Francois, right, Sylvian?
Yes, sure. So Jean-Francois is asking how will be watched and controlled the manufacturer's statements and data?
Control, do you mean?
I think you mean how you check.
Maybe like safeguarded.
I seem to understand it's related to ECODESIGN and energy labeling, perhaps, right? For first part of the presentation. Of course, the control exists, and it is the responsibility of the member states. Each country in Europe, each member state sets its own market surveillance authorities and plans. So it is the governments of the countries, of the member states, that initiate the market surveillance authority activity and decide how to proceed on checking and, of course, on punishing in case they find some incorrect information or incomplete data or on products circulating in the market.
Thank you. I think we have a question also for Miriam and for Giacomo if they want to come back. We have a small discussion. We have a few minutes, I think. Miriam, we have a question for you from Laura. As we were, anticipating, Laura was waiting for doing a question. Is R32 authorized for domestic air conditioning in the EU until 2025? Laura asked.
Okay. Hello, Laura. Nice to know from you. Thank you for your question. So R32 is allowed in residential air conditioning, except in the case of room air conditioning, mobile room air conditioning equipment. Mobile room air conditioning equipment has a limit of 150 of GWP limit. So R32 is out for that application, but for the rest of applications can be used, and indeed is one of the trends here in Europe now. It has to be into account that R32 is slightly flammable, HVAC, and so the safety standards have to be respected.
One question from Giacomo, if Giacomo is here with us. Giacomo, are you here with us? Or I make you later, maybe, Giacomo. I think we.
I am here. I'm here.
Okay.
Yes.
Okay, Giacomo. Sandro is asking, does the compressor for ultra-low temperature application follow ASERCOM indication? Is any ASERCOM indication for ultra-low temperature application?
No, there is no directive from ASERCOM.
Okay, so it's more up to the manufacturer.
Yeah, there is no guideline for those compressors. The only normative applying is the ones mandated by the machinery directive. So it is 12900 for performance, 13771-1 for testing, and 12693 for designing.
Okay. Another for you, Giacomo. You're popular today. Gaetano is asking, in a cabinet, maybe also for Francesco, but Francesco, I think, let's listen to this question. In the cabinet, did you think to put a compressor and next to it nitrogen to work cryogenically in a cabinet system? I think you never thought about it, but let's hear from you, Giacomo, or from Francesco, if you thought about a compressor plus a cryogenic nitrogen, liquid nitrogen in space.
Well, from a compressor standpoint, I see it hard to combine, but we are open for suggestions. The only point that I would like to highlight is the following. I mean, we have to not invent anything new, because any new development in this sense will require specific life testing, which is lasting months or years. So yes, we have to rely on actual technology without modifying the basic configuration too much, because otherwise we produce a lot of unknowns.
Thank you, Giacomo. Thank you, Miriam. Thank you, Francesco. I think your section was very good, and I hope you can stay till the end, because at the end of a conference we will have a all-together discussion, if you don't mind. Okay.
Thank you.
Okay. See you later.
Looking forward.
See you later, Miriam.
Yes.
See you, Francesco. Ciao, Giacomo. Okay, next speaker is Ernesto Ravello from Chemours. I asked him to come with a video on and with the audio on, if possible. Ernesto. Ciao, Ernesto. Hello, Ernesto.
Hello.
I think I put the notification to you for sharing your screen.
Correct. Yes, I'm going to share right now.
Very good. Ernesto from Chemours is going to talk to us about emerging technologies for sustainable refrigeration. We can see your screen, Ernesto.
Okay, everything is working. Correct. Perfect. So let me start. Thank you very much to Centro Studi Galileo for organizing this very interesting webinar, and thank you for letting us know participating. I'm Ernesto Ravello, Sales and Business Development Manager for Chemours Fluorochemicals, responsible for Portuguese, Spanish, and Italian markets. Today, just let me briefly introduce the concept of the refrigeration industry and energy efficiency. As you can see from this study coming from the EEA in 2019, you can see that mostly around 80% of the total EU greenhouse gas emissions in CO2 equivalent tons are related to energy consumption. So the most important challenge that now European Union has to face in order to achieve climate neutrality by 2050 is to address the energy consumption as a great priority. For this reason, I'm introducing you the TEWI concept, which is the total equivalent warming impact, which is related to the total emissions. You can see from the formula that this is considering both the GWP of the refrigerants, while on the second part of the formula is taken into consideration the impact of the energy consumption of the systems. And as you can see in these two graphs, related, for example, in this case, to the total greenhouse gas emissions in the EU in 2017, you can see that more than 80% is related to CO2 emissions. While when we speak about F-gas regulation, in order to achieve HFC reduce, you can see that the HFCs are contributing only to a 2.5% to the total greenhouse gas emissions. So that's why it's very important to consider the total emissions of the overall system. Let's go down inside the phase down and our new Optonic cell products portfolio. We divided this table into two main parts, one related to refrigeration, the second one to AC and heat pumps, and we divided all the refrigerants into three sections. So with the average GWP present on the market in 2017 with a value of around 1,900, then in 2021, which means next year, we forecast an average GWP of 900, and in 2030 an average GWP of 400. You can see in orange color the commonly used refrigerants, like for example 404A, which has been banned starting from 2020, and 410A for AC and heat pumps. While in blue you can see our medium-term solutions supplied by Chemours, like the commonly used 449A and 452A for refrigeration, and XP10 for 13A for AC applications. While I would like to point out the most important part of the graph is the green ones, which are related to new A2L refrigerants that we consider as a long-term solution. These are new developed refrigerants already available on the market. And as you can see from the values of GWP, for example, in the case of 454C below 150, they are compliant not only until 2030, but even after this date, when the Kigali Amendment will start globally. So these are our new solutions considered for the new potential markets like refrigeration and AC and heat pumps. But now let's go deep inside first a safety risk mitigation comparing A2Ls and A3s. As you can see from this table, which is the ISO 817, A2L refrigerant has been introduced with a proper classification. So you can see that they are considered as mildly flammable. And the most important characteristic of this A2L refrigerant is that the flame propagation should be lower than 10 centimeters per second. You can see there's a clear differentiation between the common A3s like propane, which are considered highly flammable, and the A1s like 404A, which are considered non-flammable. But if we go deep inside the technical characteristic and the flammability properties, you can see from this table that on the right side, we are considering 454C, for example, XL20 with GWP below 150, and on the left side, propane. You can see, first of all, the lower flammability limit in the case of XL20 is like 4 times higher compared to propane. Then the minimum ignition energy required to ignite these A2L refrigerants is around 2,000 times higher compared to propane, which can be ignited only with a simple spark. And then, for example, the burning velocity, you can see that in the case of XL20 is just 1.6 centimeters per second, while in the case of propane, we are speaking about 46 centimeters per second. So in order to resume and have a clear differentiation about the safety risk mitigation, we saw that A2Ls are inherently safer, much safer if we compare to A3 refrigerants. For example, A2Ls are less likely to form flammable concentration due to the higher LFL limit, enabling, in this case, larger charge sizes for larger application ranges. In addition, A2Ls are harder to ignite, much harder to ignite, and make them much safer to use with the most common electrical components. And finally, A2Ls are much less reactive and have a lower combustion energy, as we saw. So this means that A2Ls generate milder ignition events. So in order to resume the three most important characteristics that shows the safer flammability properties comparing A2Ls versus A3, for example, in this case, propane, 4 times more A2L is typically needed to form a flammable mixture together with air. 2,000 times more energy is typically needed to ignite A2L gases, and around 5 times lower combustion energy is released when A2Ls are ignited. But as most of you probably saw in recent white papers and studies throughout this year that we released as GEMURS, which are the most important selection drivers when considering new refrigerant solutions for commercial refrigeration. In this case, we pointed out in our studies, theoretical studies and then practical studies, that economical and environmental efficiency are the most important drivers. And if the retailer in his decision criteria needs to look for a very low GWP alternative solution compared to the old 404A, in the results of these studies showed clearly that Opteon XL20 and Opteon XL40 has the best results. Why? Because they can match the cooling performances of 404A, they exceed the energy performance of 404A, they also match the system uptime, minimizing the risk to trade, and they match the total cost of ownership. But one of the other most important characteristics is that they can match the ease of installation and maintenance. Because if we compare to 404A, these systems running with the XL20 or XL40 are direct expansion systems. So if you are used to work with 404A, you don't have any kind of problem working with XL20 and XL40. In addition to these characteristics, we showed in our studies that they can reduce the total CO2 emissions by up to 20%, and with the lowest life cycle cost and the lowest CO2 abatement cost of all the alternative technologies that we consider, including also CO2 systems with different technologies. But these were related mostly to theoretical studies that are related to real application case studies. So I would like to show you now briefly in this slide a resume of all some of the real cases that are already running in the market with both with XL20 or XL40. You can see that there are some names of important retailers, for example, Asda in the UK and Central England Co-op as well, that started running in October 2019. Some examples of cold warehouses, for example, in France. And the most recent one, which is a Spar supermarket, which has been the first A2L supermarket running in Spain. This is running since last month in October 2020 with the XL20. And I would like to present you, in order to show you that this is a real case, the most important characteristics of this Spar retail store. In this case, this is the real picture of the supermarket running with a total charge of around 50 kilograms of 454C. The total shop surface is 600 square meters with a total cooling capacity of 40 kilowatts, including MT plus LT in 18 services. The condensing units are 2 of 20 kilowatts each, supplied by Grupo Disco, which is one of the most important wholesalers in Spain, and the compressors are coming from Emerson. Regarding display cases, they were supplied by Kotska, which is one of the most renowned Spanish OEMs, and the control units and expansion valves from Danfoss. I show you here also the link to the publication where you can find more details regarding this supermarket. But we have much more already prepared for Spanish market and Southern European markets. So thank you very much for your attention. I leave here in this slide my contact details, my email, and the link where you can contact us in order to receive our periodical bulletins. I leave now the stage open for any possible.
Thank you, Ernesto. We have many questions for you. We give some priority to the questions, but we will answer to all the questions, right, Sylvia?
Sure. So let's start with Sydney. So hello, Sydney. The question is, what would be a low GWP option for the R23?
Yes, in this case, I can say that our top management in the US, and this is an info that I can disclose without any problem, is directly working together with the most important pharmaceutical companies in the US. So they are directly connected with them, try to give solutions for this new vaccine topic that is running just in these days. But I cannot disclose any more information on that. But I can assure you that our top management in the US is strictly connected with, for example, Pfizer and Moderna. They are working together with them.
Okay, so thank you for this. And now we have a question from Jose. He is asking about R513A. And he is asking, as it is a A1 low GWP alternative, why do you think it is not succeeding in the market against others like A2L with similar GWP?
But we see that this solution is higher if we compare the GWP or new A2L solutions like XL41, for example, in the AC applications. In this case, we see that in AC application, for example, R32 has already taken place inside the markets, so but with a higher GWP if we consider this aspect. So for 13A for sure is a very good replacement for 134A, but we consider it as a medium-term solution because with the GWP of this refrigerant, we are not sure that it will be available even starting from 2030, where the average GWP on the market will be around 400. So that's why we are considering it as a medium-term solution until probably 2025, between 2025 and 2030. But then, for sure, the market will need to transition to really low GWP solution like our A2Ls.
One quick question from Jean-François.
What are the glides of those two refrigerants that you present? Yeah, it probably concerns the examples that you made before. He's asking, what are the glides of those two refrigerants and how did you do the comparisons using medium range evaporating temperatures with the glides?
Okay, we use, of course, mean average temperature in our comparison, in our studies that are downloadable from our web page. In the case of the glide, for example, on the XL20, we are speaking about around 5-6 degrees K. So it's perfectly manageable with the new electronic controls available on the market. So we don't see any particular issues with this value of glide. So in order to answer to your question.
Thank you, Steph. Thank you, Ernesto. Stay with us for a debate at the end.
Sure.
Please. So now we can go with Stefano Fedeli, General Gas. I ask Stefano to turn on the cam. I can see you, and turn on the audio. I hope I can hear you. And I give you, yes, we can hear you very well. Ciao, Stefano. Let's put you as presenter mode. Okay, have a check. if you see the notification. Yeah, you see notification. So Stefano is going to talk about the cold chain facing F-gas challenges ahead. A2L best solution matching EN 378. Thank you so much, Stefano. The floor is yours.
Thank you and good afternoon to everyone. Thanks to Centro Galileo for inviting us to this very interesting super webinar. Thanks also to, just a moment, because I see my camera in the screen. What happened?
Can you
see the presentation?
Yes, very well. Click on outside your video, your camera, and you will see again the PowerPoint.
Okay, perfect. Okay, now it's okay. Okay, thanks also to Honeywell International for sharing with us this new presentation about the guide for the EN 378 application in regards to the refrigeration systems design with the H2L, the new very low GWP refrigerants based on hydrofluoroolefins molecules. And so having the new H2L classification that was introduced by ASHRAE based on the international standard ISO 817. We want to support you through the risk assessment, since it is necessary, in order to minimize the overall risk for both the production company, for both the installation companies, and so on. So basically, what we have in the market now available since some years, we have the pure HFOs, like the 1, 2, 3, 4, YF and ZE, and the 1, 2, 3, 3, ZD. These are pure HFOs already available. And since some years, the new very low GWP blends like Ernesto Revello Vecchemurs introduced before, by Honeywell, we have the blend Solstice L40X, R455A. The new very low GWP blends are basically composed by the pure HFO molecules in blend with the other molecules. It's very important to notice that these very low GWP refrigerants has got a GWP under 150 because the GWP more than 150 is not allowed from 2022 for new multi-pack systems for commercial use, with a capacity superior than 40 kilowatts refrigeration power. And I remind you that there is no ban for using virgin refrigerants even with the GWP less than 2,500 for service and maintenance on existing systems. So today we will explore EN 378 for new systems. We are speaking about, in particular, of the Solstice L40X that is made by the HFO molecules. Let's see some details. The R455A has got a GWP less than 150. The ASHRAE classification is HUL. The PED group is not 2, but it's group 1. The capacity is very close to 404A, and the efficiency is higher than 404A, around 10% higher in TN and BT classic applications. And regarding the HFO molecules, the ZE you know very well, probably because it's commonly used for chillers. The GWP is negligible, less than 1. The ASHRAE classification is HUL. The PD, in this case, very particular, is group 2. Capacity, it is a replacement of 134A, is 20-25% lower than 134A. The efficiency is a little bit higher than 134A. And the YF, what about the YF? You know very well, because it is used in the mobile air conditioning in cars. And okay, HUL group 1, very close to the 134A. Let's go to the other slide. We need to know the most important characteristic of the A2L refrigerants in order to proceed with the E-entry78 analysis, risk assessment. So it is easy now to find all the data that we need to introduce to calculate, for example, the maximum allowed charge in the systems. I report these data in this slide, but we are available for you if you want to go into deeper details. So these values are important to proceed with the step further. The E-entry78 safety standard in brief consists in 4 parts. It covers the needings of different subjects, different parts. Okay, for example, designers, manufacturers, installers, maintenance, technicians, and operators to the system in the supermarket, for example. It is 4 parts, and every part, for example, the manufacturer, the parts interesting for a manufacturer are particularly the part 2 and part 3, and so on and so on. The E-entry78 is harmonized with the European Pressure Equipment Directive, the PED, and the European Machinery Directive 9837 EC, with respect to the design, construction, testing, marking, documentation requirements. Locally, state by state, there may be additional directive, national regulations. So it's very important, and it's a responsibility, sorry, of the contractor and the operators to understand and comply with the local requirements. The risk assessment, basically, for a new, repeat, a new refurbished installation, it's needed to check the following matters: the required refrigerant charge, the location of the system components, the occupancy of any room containing refrigerants or the components, and this is valid for every refrigerant, no matter which refrigerant you use, flammable or non-flammable, because there are dangers in every pressurized gases that you may use. Of course, for the A2L, it's necessary to perform a risk assessment. Important steps of the E-entry78, for example, are the occupancy and the system location checks. In the case of a supermarket, for example, the occupancy is categorized in 3 different categories: general, supervised, and authorized. The machinery room, for example, and cold rooms are into the authorized classification. The sales areas in which there are persons working like me, etc., is general occupancy. And what about the system location? Where are the refrigeration system components installed? This is important to understand for the E-entry78 assessment. Examples for a supermarket: the class 1, or refrigerants containing parts in occupied space; class 2, compressors and pressure vessels in machinery room or in open air; the class 3, or refrigerants containing parts in machinery room or open air. So it's important to classify. So building such a quick and easy guide for charge size calculation, especially for the supermarkets, after having studied the E-entry78 in detail, after having engaged consultants specialized in this particular matter, we created this quick and easy guide. Today, we will see only one example, because it's impossible to see everything. We will see the centralized direct expansion system with the machinery room, with the multi-compressor pack, and the condensing pack in the open air. And we will focus, as an example, with the R455A, the new Solstice 40S by Hanwell. We check if everything okay. We are speaking about centralized direct expansion system with machinery room. So it's okay. We check the picture on the right. Is it what we have in our mind? Is that our project? We are focused on that. Okay. So we can go to the red rectangle we see in the bottom, and we can click it, and we will be taken to the chart 4 for the 455A refrigerant. And so we can see how the charge, the maximum allowed charge, are reported into this graph. We have in the x-axis the area, the surface area in which there are people, technicians, and so on for every kind of occupation. And in this case, we are examining the access category A, so general occupancy. The system location is the system location 2. There are many things to notice, but I would like to bring your attention to the fact that we can go up to 84 kilograms with the R455A. So it's a good charge per every single circuit. In the case the power is, maybe the supermarket is very large, for example, 2,000 square meters, and we need to respect the N378, we can divide the system in for example, 2 lines in TN, 1 line in BT, and so we can be within the 84 kilograms required. Of course, we can have safety measures applied. With the green, we see a standard system. As we reduce the area and we increase the charge limit, the charge, we may have to add additional safety measures. Other features that are included in this tool, of which we have seen only a very quick resume, we can have in this tool that is already available the guidelines for the machinery room, to design the machinery room, the guidelines for the electrical supply infrastructure, the PD compliance considerations to help the project managers, a full guide for many kinds of system architecture, not only this one that we have seen that is very simple. Of course, as I already told you, this guide is already available, so you can contact us for additional info, or you can read, for who receive it, you can read the Honeywell communications. In some of that, there were the links to this interesting tool. We also had a risk assessment checklist just to guide you through the creation of this charge size calculation path. It's a guide. It asks you some details about your system. You fill into, and then you are guided through the N378 assessment. Thank you very much. It has been quick and it's very condensed resume. The guide is very detailed.
I think you gave the point, and it was very nice because you gave an indication where to find the guide. And I think you raised an important problem, which is the risk assessment. I think we have one question, Silvia.
Yes, sure. We have one from Barbara instead. She's asking how many installers know what they will become constructor of the system and must do the risk assessment checklist.
Well, I'm not sure I have understood the main topic of the question.
Is the contractors, the installers, know that they need to do the risk assessment because they become constructors?
Good question. Good question. They must know. They must know. The N378.
At the moment, they know it or not?
Sometimes yes. How can I answer to this? It's very. You know, it's very. There are many installers, so it's difficult to answer. But the most important contractors, they know this. They know that there is a path to be followed to comply with the N378. But the N378 is not a free, as you know very well. It's not a free safety standard. You have to buy it. You have to read it. It's very long. It's not complicated, but it's very long. So, but there are many consultants in Europe and even in Italy that can help you. Of course, you have to pay something, but not a huge amount. They can help you toward an N378 compliance of the system, if you are a designer and if you are an installer. So it's everything ready.
Okay.
It's just
Okay, maybe for small installers it's not easy as big installers. So maybe it's more difficult. Okay, we are 15 minutes behind schedule, but I think is understandable. And I would like, Rodolfo is here already, so thank you, Rodolfo. Thank you, Stefano. Thank you for your presentation. And please stay with us for the discussion. We will have a small discussion with your session in a few moments. So now we have Rodolfo. I will give you the
yes, please.
To share the screen. I think you can see.
Great.
So Rodolfo from Luve, thank you very much, Luve, for helping us every time for this kind of webinars to increase knowledge.
It's a pleasure being part of this.
Always very informative, your presentation, so I'm very happy for you to be here. Rodolfo will speak about, Rodolfo Cavicchioli will speak about next generation of low GWP refrigerants, challenges and solutions. Thank you.
Yeah,
Rodolfo.
so thank you, Mark. Thank you for the introduction and thank you for the opportunity of being here. And welcome everybody to this presentation. In this presentation, I'll talk to you about the next generation of low GWP refrigerants, what are the challenges and the solution. I'm Rodolfo Cavicchioli, as you can read from my first slide here. I'm product manager of Luve Group. Luve Group is a manufacturer of heat exchangers. So I'm not an expert of refrigerants, but I want to do this presentation about this next generation of refrigerants because it's important that people understand what the next challenges are in dealing with these refrigerants and the solutions that are available in the market from a supplier as Luve Group. So briefly, the agenda of the presentation, we'll go through these points. We will see the regulation, the European regulation 517 of the year 2014, the so-known F-gas regulation. We will see the average GWP in the European market needed to follow the phase-down regulation. We will introduce this new generation of low GWP refrigerants, specifically as an alternative to R404A, the most common refrigerant used in refrigeration. And the characteristics of these refrigerants, this being the temperature glide and the flammability. We will see how to design and rate components, so evaporators and condensers with the refrigerant with high temperature glide, and we will see how to deal with the flammability issue, and that has to be taken into consideration, of course. And at the end of that, we will draw some conclusions. Okay, so let's dive deep into the regulation, the F-gas regulation. I'm sure that most of you are sick and tired of this face-down graph. So it will be fast enough. This is I just want to point out some things in order to introduce the next slide. So we have this face down graph showing the quantity of tons of equivalent CO2 in the European market. There has been a baseline established, that is the value that we had in the market in the year 2015, and we have this gradual reduction of the established baseline quantity in terms of, as said, total equivalent of CO2, with a value of 21% of what it was in the year 2015 by the year 2030. Again, this is what it is for the European market. We have, besides that, the Kigali Amendment with the same similar structure, but just with different step in different years. So the phase down program aims to reduce the use of fluorinated greenhouse gases, in particular the use of those fluorinated greenhouse gases with high GWP. The quantity of refrigerant that can be sold across Europe is measured in tons of CO2 equivalent. And another thing that is important to say is that the phase down is not refrigerant specific, but looks at the overall CO2 across all gases manufactured. This scheme will encourage manufacturers to move to lower GWP gases in order to produce and to sell in the market the same kilograms per year of refrigerants. So if we want to do this exercise, we can say that in the year 2015, the total refrigerant sold in the European market in terms of kilograms had an average GWP of 2,250. And if we want to maintain this same amount of refrigerant in kilograms as we go through the phase down, we will see that that in the starting from the 1st of January 2021, so basically in 2 weeks' time, we will need to have an average GWP in the market of around 1000. We have seen in the previous presentation that these values has been calculated in 900. There's no big difference between the two values. So again, this phase down is not refrigerant specific. So I'm not saying that the use of a refrigerant with GWP higher than 1000 is not allowed. We are just saying that the average GWP in the market, starting from the 1st of January 2021, must be below 1000, and this is important. So what are the two paths that we have in front of us in order to achieve the requirements of the phase down? So we have the first path that will drive us in the direction of natural refrigerants, so forgetting about the fluorinated greenhouse gases and moving to something different. We have the CO2, we have hydrocarbons, we have ammonia, we have plenty of solutions. But if we want to stick with fluorinated greenhouse gases, so HFC, HFOs, and blends of the two, we need to move in the direction of blends with lower GWP. Okay, so here I want to focus on what is the situation now in the refrigeration business. So in the refrigeration business, we have been used since many years to work with mostly with R404A. This refrigerant is really bad from a GWP standpoint. The GWP of that refrigerant is almost 4000. So we have seen in the last years a replacement of new installation, switching from the use of 404A to the use of some different refrigerants. So we have seen 448 and 449 that have an average GWP of 1400. And for this refrigerant, we have seen that the fact that we can go lower in regards to the 4000 GWP or the 404, we can go in the direction of low GWP refrigerants, but we have to deal with the refrigerants with higher glide in comparison with R404A. Tomorrow, if we want to try to get below the 1000 GWP value, we need to move to some other refrigerants. And we have seen in the last month some new refrigerants coming into play. And this is the next generation of HFC, HF4 refrigerants for the refrigeration business. So we have seen refrigerants such as R455, 454. These refrigerants have a GWP of almost 150, so way beyond the 1000 we wanted to go below. And yeah, these refrigerants have two main characteristics. They have a high temperature glide, in some cases really high temperature glide. For example, R455 in standard evaporator pressure and temperature condition have a glide that can be more than 10 Kelvin, and they have the flammability issue. This refrigerant being blends of R32 and R1234 mostly are ASHRAE safety classified A2L, so slightly flammable. So let's concentrate on these two characteristics. First of all, concentrate on the glide characteristics and understand what this means and how to deal with that. So this is a small introduction of what the scenario is when dealing with blends of HFC and HFO. We have two different families. We have the pure refrigerants, meaning that they are composed by a single component. An example of this is, for example, R134A. Or we can have the blends, meaning that the refrigerants are composed by two or more components. These blends can have different characteristics, and if we want to analyze these characteristics, we have to divide these blends in three categories. So we have the isotropic blends, meaning that the refrigerant has a constant boiling point, meaning basically that the components of the blend have the same boiling temperature. We have the near isotropic blends. An example of this is the beloved R404A. Near isotropic means that basically the physical properties are can be considered isotropic, and we have the zeotropic mixtures, meaning that the refrigerant does not have a constant boiling point, meaning basically that the components have a different boiling temperature. And we can see here that the refrigerants that we have seen in the previous slide, so 448, 449, 455, and 44454, see, are zeotropic mixture, so they have a temperature glide. So how to deal with the temperature glide, what it is, and what is the impact in designing and rating and an heat exchanger, an evaporator, and the condenser. So here for you just to try to picture out what the refrigerant wind glide means, I have decided to use a temperature enthalpy graph, even if it's not the most common way to represent the refrigeration cycle. And here you can see in blue refrigeration cycle with a refrigerant with no glide. I have indicated here in yellow the dew point. The dew point is usually the temperature values of both the heat transformation of evaporation and condensation, and it is normally used to rate the unit and to design the unit with the selection softwares. If we consider these two values to be the same, when we switch from a refrigerant with no glide to a refrigerant with glide, we see that we have a totally different refrigeration cycle. In particular, due to the characteristic, so this temperature glide, we have an increase of the delta T on the evaporator, meaning an increase of capacity, this being almost proportional to the temperature difference. And we have on the other side of the refrigeration cycle, on the high pressure side, we have a decrease of delta T in the condenser with a decrease of capacity. So how can we deal with that? How can you compare and rate the unit in similar condition when switching from a refrigerant with no glide to a refrigerant with glide? And we have here the answer to that. So we can use the mean point of the evaporator and evaporation and condensation processes. The mean point is by definition the mean temperature of both the processes of evaporator and evaporation and condensation. And using the mean point for designing and for rate the unit, we can compare the performance of the unit that work with different refrigerants. Of course, in doing so, we are just basically trying to compare the unit in the average working condition. But it is, again, this is a good way to work with the refrigerant with glides, especially if the refrigerant that we were used to working with had no glide. But we could have a problem in doing so. So in using mean point, I don't want to use the word problem because this is not a problem. This is just something that we need to take into consideration. And this is the superrating issue. And you can see here what the problem is. So evaporator as one of the goals is to superheat the refrigerant in order to avoid the risk of having liquid droplets that comes in the compressor. So we need to superheat the refrigerant at the end of the evaporation process. So it's important to consider the real DT1, the so-called DT1. In the technique, DT1 is the temperature difference between the cold room temperature and the dew point. Dew point is the point at the end of the evaporation process, so where when we encounter the saturated vapor curve. And of course, we can see that if we consider the mean point to do the calculation, we will add at the end of the evaporation process, we will have a very different DT1 in the two cases. We will have this DT1 in a case of a refrigerant with no glide, and we will have this much smaller DT1 in case of a refrigerant with glide. And of course, this is a problem because we have to take into consideration that we need to have this DT1 large enough in order to properly superheat the refrigerant at the end of the evaporation process. And if we forget to do so, we can counter some problems. We have a problem in the designing phase, so we will have a not accurate calculation. We can have results that may be not completely reliable and not completely accurate again. But the most important is the fact that on the field, if you forget to consider and to analyze if the DT1 is large enough, we could have the expansion valve that will continuously close in order to reach the set point. We will have the evaporator that will be superheated for the major part with a dramatic drop in performance. So again, there is no using the mean point is a good way to design and rate a unit working with high glide refrigerants, but we have to take into consideration that we have to take seriously this DT1 thing, and we have to guarantee that we have a large enough DT1 to guarantee proper superheating. If we switch to the other let's call it issue that we have with this new family of refrigerants, that is the slightly flammability, we have to take into consideration that we as manufacturers have to guarantee the safety of operation. So manufacturers of refrigeration components in general need to take into consideration this flammability issue, and units components have to be designed with special components and special attention in order to be compliant with the use of these A2L refrigerants. And starting from the first quarter of the next year, Luve Group will introduce this new full range of commercial unit cooler that is fully certified for the use of A2L refrigerants. The name will be with an S in front, and that stands for safety in this case. So we are fully ready for the use of these refrigerants. Just to draw some conclusions, so we have seen that on January the 1st next year, we will have this second B step in the phase down process, and the total number of tons of equivalent CO2 will go down to 45% of the value that he had in the year 2015. So that's a big drop. In order to have the same amount of refrigerant in the European market in terms of kilograms, we need to have an average GWP of the refrigerants in the market below 1,000. Speaking of refrigeration, now we are using some substitutions to R404A that have 1,500 of GWP. The next generation of low GWP refrigerants for refrigeration have less than 150 of GWP, but we have a high temperature glide, and we have this slightly flammability characteristic. So glide is important to know what it is. It is important to know how to deal with that. Using mean point to the calculation is a good way to compare performance when switching from R404 to these new refrigerants. But we need to take into consideration the superheating issue. So we need to consider that we need to have at the end of the evaporator a DT1 large enough to guarantee the superheat. And regarding the A2L, so the slightly flammability, we as Luve have developed this new range of commercial unit coolers that is ready and certified for the safe use of A2L refrigerants. So that's all from my side.
Thank you, Rodolfo. Thank you very much. It was very comprehensive and very informative. We have one question, right, Sylvia?
Yeah, we have a couple. So the first one would be from Jean-Francois. He's asking if you can point out the difference of the COP calculation using minimum evaporation temperature compared to the reality of the glide.
So I'm not sure I get the question. So when we deal with in our selection software, for example, when we deal with the mean point calculation in evaporator, in the evaporators, we consider the evaporation process. So we are not consider the whole, let's say, from the bubble point to the dew point, and then consider the average point and the average temperature. We are considering the real transformation. So in the and so we are considering in our selection software the mean temperature exactly as it will be in the evaporator. And so there won't be I don't, yeah. Was it the question? I'm answering the question.
I'm not sure, right? Because of course Jean-François is writing the question, so maybe he can formulate better the question. I have another question for, we can start a small debate with also Stefano Fedeli, because we have also one question which is for Stefano or for Rodolfo. Stefano, you first. In air conditioning application, the 20% low flammability level limit for a free refrigerant is still considered in the EN378, or any changes is expected? This is a difficult question, I believe. It's from Kundlik.
Yeah. Yes. The answer is to me easy. Maybe not, but to me is easy because the EN378 covers almost all the HVAC and R appliances. So from the air conditioning to refrigeration. So all the answers to the allowed charge, to the differences between R290, R600, and the HUL gases are contained into the EN378, let's say, exhaustive assessment.
So I think we can carry on later with the debate. If you can please stay with us, Rodolfo and Stefano, at the end of the webinar at around 4 o'clock, 4:15 o'clock, we will have a debate all together. Okay? See you in a bit, Stefano and Rodolfo. Next speaker for us will be Sergio Mozzato from Vigam. I ask Sergio to come to put your camera on, please, and also your audio on, if possible. I will put you as presenter. Sergio, hello Sergio, ciao Sergio. Okay, Sergio, we can see your presentation. Okay, Sergio will speak about equipment. Is important equipment and tool to be used with a new low GWP refrigerant, equipment for hydrocarbon and for CO2. We should remember that we have good technician only if we have good equipment. Thank you, Sergio. The floor
Good afternoon, all, and thank you so much for Centro Studi Galileo for this invitation, and thank you so much for Marco, Alberto, and Silvia for this perfect organization. So my name is Sergio Mozzato, and I am area manager for Vigam. Now I show you this fast and quick presentation named equipment and tools to be used with the new low GWP refrigerants, equipment for AC and the CO2 system. So before to start with my presentation, I would like to spend only 1 minute to introducing my company. So Vigam is an historical Italian company that develop system and instrument for air conditioning and refrigeration. So Vigam is not only present in the HVAC market, but also is present in the AC market. Only to understand, we are present in the automotive market. We produce the station for the service for the garage. And I think this is a strategical position for my company because we have the complete overview for all the refrigeration market. For this reason, we are present in the refrigeration market and also in the automotive market. So the market in the last year and in the next year will change. Will change because there is a lot of regulation, a lot of the law introduced in Europe that change the move, change the work of our customer. So, for example, the very important regulation introduced many years ago is the 517 regulation, is the phase down refrigerant HFC. So I resume this regulation with these phrases. The noble objective of this regulation is to protect the environment by reducing greenhouse gas emission. So the important things of this regulation is the step HFC reduction for the 2018 equal to 63%, for the 21 to 45%, by the 30 at the 21%. This means minus quantity of the refrigerant present in the market. So there is a different solution regarding this issue. The first is the evolution, and the best practice should help achieve these targets. So its priority to drastically reduce leaks through best practice aiming and preventing the per-service. What mean that? Would mean that any singular operation to install the system, to maintenance the system, is to do better. Joints, pressure test with nitrogen or azo mixture. So to do better, the vacuum test with the high quality vacuum pump and the high quality vacuum meter digital. So reduce the collateral and the manumission when you connect and disconnect the tools to the system. Recovery, use the specified recovery units. Top refrigerant traceable. This is the first step. The second step is the developing and spreading the practice of the recovery, recycling, and the recovery. The third step that we are promoting is developing and spreading the use of a refrigerant with a lower GWP or natural refrigerant. So I think, and we think, is the future is the natural refrigerant. For this reason, we are ready for the large range of the tools and equipment for the hydrocarbons. Hydrocarbons means isobutane, propane, and this refrigerant is classified R-free refrigerant. What means R-free refrigerant? Two things, especially. The first thing, this refrigerant, propane, isobutane, the 219 or the 600, have the lower GWP. The second thing, very important, that this refrigerant is much more flammable, is flammable gases. For this reason, it's not possible to use tools and equipment that our customer use for the actual refrigerant. It's necessary to use special tools, special equipment when you work for the free refrigerant. For example, it's necessary to use the specific vacuum pump. It's necessary to use the ATEX vacuum pump, allow you to work safely, even in ATEX 2 zone is generated in the event of the exceptional failure. For this reason, it's necessary that the vacuum pump have the motor, okay, with the ATEX certification. It's necessary to use specified tools like the manifold. Some standard equipment and machinery can also be used safely flammable refrigerant. For example, the manifold. Manifold D6, okay, have been specially designed with the appropriate scales for propane and isobutane. Also, necessary to use a special tools, special access valve to minimize the potential connection leaks. So Vigam is the first company in Europe that introduced the digital manifold with the ATEX 2 certification. Fox X is true specifically to support refrigerator service operation on plants employing free refrigerants such as propane and isobutane. Also, we have leak detector specified, okay, for the AC, and we introduced the Easy Cap, a self-driving caps to close the end of the service pipe. This is important for our customers that have a little production, or for our user and the user that have the maintenance and the service for the system contains the propane. Also, important thing is to the recovery, the propane. Okay, propane have the lower UV, but when you work for this system, it is possible to recover this refrigerant. So it's important to understand that the standard recovery equipment cannot be used safely to recover flammable refrigerant due to potential trigger source. It is necessary to use the manual reco pump, manual recovery units, and then we introduce this manual recovery unit that is possible to use for the AC refrigerant, and we have the good result because, only for your information, recovery liquid for the propane we have 320 gram minutes. In vapor, 72 gram minutes. So I think it's a good result for the manual vacuum pump, for the manual recovery pump. Also for the container to recover the propane, the recovery cylinder for the HVAC and EPREL refrigerant is necessary that are red. Always evacuate the recovery cylinder to remove the air before entering the flammable refrigerant. When recovery hydrocarbons refrigerant in the bottle, do not fill the recovery cylinder more than 45% of the SFC weight safe limits. Also, the last one we introduce in our catalog the special equipment for our customer that have a little production to switch to the R404 to propane. We have the compact ATEX that is an automatic service station for evacuation and charge of refrigerant plants. This unit is ATEX Zone 2 certification. We have the integrated ATEX vacuum pump. We have great precision because the system that contains propane need to have the great precision when you charge the refrigerant. We have the high precision injection system like 2 grams for quantity minus 5 kilo. We have the built-in precision vacuum, so it's a real small workstation that permits for our customer to work for all the service operation to install or maintenance the system. So we change our focus, we pass to the hydrocarbons for the CO2. So CO2 is the natural gases, is a not flammable gases, is the class 1 refrigerant, but we have one problem. The CO2 work for the high pressure. In transcritical installation, pressure can reach up to 120 bars, while in subcritical cascading system, you can reach up to 45 relative bar. The pressure of the cylinder is high, for example, 90 bar relative, when the cylinder is a temperature of 40 degrees Celsius. Also, for the hydrocarbons, also for the CO2, it is necessary to use the special equipment and special tools. Pressure gauge, flexible hose, bottle fitting, nitrogen pressure is necessary to have the technical features specific for the CO2 because we work for high pressure. For example, digital manifold or analog manifold, we have the max pressure 160 bar. We have the two transducer pressure in our Fox CO2, and also for the manifold, it is necessary to have the specified flexible hoses for the CO2 that we have the pressure of work for 200 bar, connection 1/4 side. And we studied and we introduced this year in our catalog the special access valve specified for the CO2 with max pressure 160 bar, extremely low volume that avoid losses gas during the connection passes and the valve is connected. Also AC, also CO2, but also we have now we have the nitrogen regulator, we have the leak detector for the CO2, but we have also tools and equipment for the AC, also tools and equipment for the CO2, but also we have our large range of our tools for the actual refrigerant. We have a large gamma of the vacuum pump that is made in Italy and is made in Vigan for the smaller vacuum pump for the bigger vacuum pump. And with this changement, we are every day, every year on focus for the our end users. So only, for example, this year we introduce this bigger flexible office named EPREL. EPREL greatly reduce up to 50% the time it takes to operate a power vacuum. This means that we have the new internal diameter of the EPREL tube up to 10 millimeters. You consider that the standard is 5 or 6 millimeter diameter internal of the flexible office. And I like to define this instrument like a multitasking instrument, because you connect the EPREL to the system, you extract the internal mechanism, you close the one valve, you we will avoid the piston nut by extracting the internal mechanism and preserving the refrigerant charge within the system. We created the new connection that you have possibility to connect or digital vacuumeter, or you have the possibility to connect the flexible also for the charge of the refrigerant. So I think it's a good product for our customer. For the end, we introduced the new patented manifold analogy, named SPY. SPY, we have the bigger glasses to see the quality of the refrigerant. So in this year, we have very, very important to understand the quality of the refrigerant. You can check visually the miscibility of oil and refrigerant, the quality of oil and the possible presence of water and polluting particle. Besides the indication of the quality of the refrigerant, you also have several visual information that are useful while checking the operation. You have possibility to see the bed oil, refrigerant miscibility, if there is the broken compression, or if the refrigerant is contaminated with water. Different solution, possibility to have with the flexible hose, carrying case or without carrying case. Our range of digital manifold is very complete, because we have, for example, the Fox One, that we have possibility to connect the scale, connect the clamp meter. We have inside the vacuum meter, we have inside the data log. So we have a complete range for all the refrigerant. Thank you so much for this time.
Thank you, Sergio.
Together, and thank you so much, Marco, for this invitation.
Thank you, Sergio. We understand that we need new tools for the new refrigerants. I think we have one question, Silva, right?
Yes, sure. We have one from Marino. So we say hi to Marino. How are the cap on tubes closed in order to be suitable for hydrocarbons?
I think it means the connection at the end of the tubes.
Yes, we have this special kind of tools named Easy Cap. With this cap, you have possibility to close hermetically the cap to the compressor, and I think it's the best solution specified for the producer, the OM, that we have the production to replacement the R404 to the propane, and I think is a good solution, this one, for also for our customer that work for the servicing method.
Thank you very much, Sergio. I think that's it for now. Please stay with us, because we have discussion in half an hour around.
Absolutely.
So thank you, Sergio, very informative. We can go to the next presentation, again about tools, because we think tools are very important in this moment, as said by Sergio. We have Michael Harris. Please, Michael, come with your video and with your audio on stage, please. Can you
hear me?
Yes, we can hear you perfectly. Where are you speaking from UK?
Yeah, from the UK, yeah.
Nice having you. I hope the weather is not so cold as we are here.
It's raining, it's England, what do you expect? Yeah, thank you, Marco, for the invitation, and thank you all for listening to the presentation. I've entitled my presentation...
130 persons listen to you, so no pressure. We have
no pressure.
Michael Harris, Back to the Future. Thank you, Michael.
Okay, thank you. So Back to the Future. what do we mean? So day one, when we all began in refrigeration school, for some of us a long time ago, many years ago, we were shown the refrigeration cycle. By refrigeration, what we're looking to do is transfer heat from one place to another heat by using a medium, which can be in fluid or in gas form. But it's a simple cycle. We want to change heat from one place to another. But where did our refrigeration cycle begin? It began nearly 200 years ago in 1850. And the first generation of refrigeration fluids then was ammonia, carbon dioxide, propane, air, and water. As we progressed and we developed, we looked at synthetics or chemical refrigerants with CFCs and with HCFCs, and we was getting refrigeration to be much more precise and professional. As we moved into the 1980s, we began to become aware of global environmental issues, global warming, ozone depletion. And so we brought out a new generation, the third generation of medium, and that was HFCs such as R134A, R404A, R410A. As we progressed into the millennium, what did we see? We saw natural refrigerants coming back into the market, particularly hydrocarbons in the cabinet industry, CO2 in supermarket cooling, and then we started to see HFOs, but also air and water cool systems coming back into the design of many products. So where are we today, 20 years into the millennium? We're seeing that CFCs and HCFCs are being phased out. HFCs are being taxed out. We're seeing more and more HFOs and different blends every month, every few weeks. We are seeing a new blend, a new refrigerant, but they're all interim refrigerants that may be with us a few years, or maybe 15 years, or maybe a little bit longer, but they are being seen as interim refrigerants. They aren't the perfect solution. Carbon dioxide is becoming much more common again. Hydrocarbons, very commonplace, especially in the European market. And we're also seeing a gradual increase in ammonia systems again. So really, we've come that complete circle. But what does that mean to us? It means that the refrigeration technician has had to evolve. Here at Fieldpiece, we design and produce our tools purely with the refrigeration service technician in mind. Back in the day, if a refrigeration system on site needed a mechanic or a technician, a guy would turn up, and as long as he had a big wrench and he could tighten the nuts and a hammer to knock on things and enough refrigerant just to top up a system until the pipes were getting cold, that was seen as being a refrigeration technician. But today, that technician has to be very technical, he has to have competency, and he has to understand what his readings on his equipment are telling him. And so the investment from the refrigeration technician is quite immense now. He has to have quite a sophisticated and varied tool bag of products and tools that he takes to a job with him. But what are the challenges that face today's refrigeration technician? One is the category of refrigerant type. No longer do we only have one type. We've got the natural refrigerant market, where with CO2 or R744, where the technician has to be able to work with toxicity issues and the high pressures of the system. He has to work with hydrocarbons. Very much flammability is a concern, but also the fact that the smaller amount of charge is used in domestic cabinets and drinks coolers, the accuracy of the refrigerant charge is very, very critical. with the chemical blends or the synthetic refrigerants, there is still a concern regarding potential flammability, but leakage rates have to be eliminated, and there is the compatibility of components when retrofitting to be taken into consideration. So today's refrigeration technician, when he goes to a job site, has many more concerns than he did 25, 30 years ago. So his considerations, number one, is the environment. We have to reduce emissions. He has to be very concerned regarding leakage, the energy consumption of the units he's working on, and for sure everything he does must be F-gas compliant. When he's retrofitting new refrigerants, he has to be aware of the component capability, the correct charge levels, and safe handling of those refrigerants. Also today, everything has to be recorded. How much old refrigerant has been reclaimed, how much new refrigerant is charged, what leak detection system was employed, and how well, and also how well the system is performing before he leaves the site. The critical charge accuracy is a very major concern, especially in, as I say, hydrocarbon refrigerants. With a smaller amount of refrigerant will have such a big effect and impact on the system performance. And the technician has to be very much aware and hold the new refrigerant performance criteria charts so that he knows what is happening within a system. For companies working on refrigeration service, the stock holding of multiple refrigerants has really changed their workshop and their storage area. In fact, also they have to log cylinder movements, not just 1 or 2 cylinders in the yard or in a workshop. They could have multiple cylinders all around the country, but they have to be aware of where they are and how much refrigerant is being contained within them. What that all adds up to is the high cost today of refrigerant gas. So today, we all must work more safely, more efficiently, and better and faster. Good tool selection and investment in tooling is absolutely vital. We at Fieldpiece design our tools, as I said earlier, only with the service technician in mind. So that means it must be high quality in performance, but it must also have reliability and ruggedness that maybe tools of 25, 30 years ago didn't quite have. So what sort of tools are we talking about that makes today's service technician's job easier, faster, and more efficient? The manifold is probably the heartbeat of checking a system. So we've all seen, used, and know the traditional manifold. A manifold block can be 2-way, 4-way to get into the system, and with a dial reading that the technician can take his reading and know from pressures what's going on in the system. But that's as long as he's working in an open space or a well-lit room. Often we're working in dark cellars or on the roof of a building, and it's not always so easy to record those pressure readings. Today's manifold and the manifold for tomorrow still has the same physical manifold block, but sitting on top of it is basically a mini computer. It's a digital manifold that can store 50, 60, 70 refrigerants. It can be upgraded. It can speak to other tools within the wireless system, and it can work up to 100 meters away from where the person that's recording the data is located. System evacuation. Previous speakers have mentioned the need for good evacuation. Absolutely vital. And again, the old style vacuum pumps still work extremely well, but were probably designed for workshop use, so they could be carried from one place to another in a workshop. In the back of a service technician's van, you know, and I know this from personal experience, normally the only oil change a vacuum pump gets is when it falls over in the van and the oil falls out. So again, we design our vacuum pumps to be as rugged and as versatile and as stable as possible, so that there is no oil spillage or problems of that nature. Leak detection is absolutely vital, as we all know. And going back in the days when we started, you was lucky if you had leak detector spray. Often you had to have washing up liquid or soapy water, and you would see a bubble and say, we have a leak, get the wrench, tighten it up. But nowadays, we're looking for leaks as low as 2 grams per year. You won't get any kind of bubble at 2 grams per year. So very highly sensitive infrared leak detectors are becoming more and more commonplace in the service technician's bag. More importantly, it was also wireless communication. As I alluded to with digital manifolds, we can communicate either back to an office or certainly to a handy mobile phone that's situated within 100 meters. But we can also bring in other products such as digital scales for weighing in and weighing out refrigerant, multimeters, pressure, temperature, and humidity hygrometers. All can be integrated into the same wireless system that can be recorded, reports created, and data logged for future use. For latest product range, we're looking at large diameter pipes where, again, for all of the 30 years plus I've been in the industry, if someone was working on a 60 or 70 millimeter diameter pipe, the only way you could take pipe temperature readings was to strap a thermocouple to the pipe work, and you'd get a reading of sorts. It wouldn't be accurate, but you could get it. But now we have a rapid rail clamp-on temperature gauge for pipe work up to 100 millimeters, where you can get accurate recordings of system temperature fluctuations, that is recorded and data logged. So if I can just summarize where we're at on the market trends. As I said at the beginning, it's nearly 200 years since Jacob Perkins patented the vapor compression cycle, basically using fluids and gas to transfer heat from one side of a system to another. The same thermodynamic cycle is still here in place. It's what we are achieving by being a refrigeration technician. But from the beginning, the refrigerants were natural, but flammability and toxicity with them led to the introduction in the 30s of CFCs, followed by the HCFCs in the 50s. And then as we became aware of the ozone layer depletion and global warming, we brought in other refrigerants again. And at that time, sustainability became a buzzword. That sustainability still remains in the industry. But it's clear that refrigerant choices that were once regarded as being sustainable weren't really so. And regulation, specifically in Europe with the F-gas regs, but also in the USA with the EPA regulations, are forcing the phase down, as we've said, to reach a target of 21% of 2015 usage by only 2030. That's less than a decade away. So now we are back to naturals, still with some chemical developments and synthetic refrigerants also, but the three main parameters which must be aligned to accomplish a sustainable balance in our industry is safety, safety for the customer, safety for the technician. But we must work environmentally compliant, but it must be affordable. So I'll wind up my presentation today by giving you a little conundrum, and would ask, why is the human brain like an umbrella? Simple answer is, neither are much used if they're closed. I would ask you all, technicians today, technicians of the future, keep an open mind to all developments that are happening in our industry. Look forward to the future, but when you invest and invest in tooling, make sure you invest in the best quality tools that you can get.
Thank you very much, Michael.
Are available today. So thank you very much for your attention.
Thank you very much, Michael. I think your conclusion was very right. We have to take care of the developments. We will see many developments in the future. We are seeing now many developments, but in the future even more. So let's have some questions. And we have a question, right, Sibian?
Yes, we have one from Ian. He's asking, at what distance does the wireless communication work? So like how broad?
In general, 100 meters, and that's through a wall or from a rooftop down to someone sitting in an office.
Okay, so it's quite, you can cover, for example, a VRV, VRF, or a supermarket.
Yeah, absolutely.
Very good range. Okay, yeah. Thank you, Michael. Please stay with us. We have a final debate at the end.
Okay, thank you.
We have another question.
Yeah.
From Fiorenzo. Do you want to read it, please, Silvia?
Sure. Maybe... I guess for Michael, if you can stay with us a few seconds more. He's saying that technology has made great strides with increasingly advanced tools, but could the refrigeration concept evolve to truly become cheaper and more efficient?
I think not just for, I think all of the European manufacturers of equipment have realized that we have to make high quality tooling. The technicians deserve and must work with the highest quality possible, but you have to build in a competitive pricing that the technicians can afford. I agree, yes.
Thank you, Michael. Very good.
Yeah, thank you.
So, I would like to call now Rivacon, Filippo Lucchetti, if he can come online for us with the video and with the audio. Buongiorno, Filippo.
Good afternoon. Do you see my screen?
Yes, you can put large. Yes, we can see large. So Filippo Lucchetti will talk about the refrigeration laboratory we have in Rivacon, and research is very important. So we are talking about COVID-19 way out, how crucial are measurement for research and development in refrigeration. Thank you so much, Filippo.
Okay, thank you very much to Centro Studio Galileo for the invitation. I'm Filippo Lucchetti, and after a significant experience in Rivacon R&D, I've been in charge of the VAG refrigeration laboratory for 6 years, following all its developing stages, from conception to implementation up to its full operation. Now I'm the manager of the VAG refrigeration laboratory. Okay. In recent weeks, a great audience has become aware, perhaps for the first time, of the importance of the cold chain, thanks to the distribution of the anti-COVID vaccine. In this slide, I have summarized for the first 2 vaccines that will have European authorization, some point relating to logistics, transport, and the storage temperature, which basically reach up to minus 70 degrees. It is interesting to see that the temperature to be kept change according to the transport and the storage phase. Many speak of very low refrigeration temperature, taking them for granted as can be done. For example, when dealing with the storage temperature in domestic refrigerator or air condition in cars. Actually, developing and testing application at low or very low temperature is not easy at all, especially in the medical sector, where obviously the regulations are very strict. This is why it is essential to have a laboratory for research and development, such as the VAG refrigeration laboratory. It ensures repeatability, accuracy, and the certainty of the data, which are fundamental for the design of refrigeration system with such high quality and performance as required by the sector regulation. The accreditation obtained for VAG refrigeration laboratory by the Italian Accredia and by ILAC and at the international level certify the reliability of our structure and offers us and our customer important benefits such as reputation, because the service of accredited laboratories are required in an increasing number of sectors by companies, public organizations and customers, both nationally and internationally. As performance, because the accreditation activity allows laboratories and monitors to improve their competence and compliance with standards and demonstrate the high quality of their work. As competitiveness, because accredited companies see their image strengthened in terms of reputation and the reliability of their commercial offers. And finally, as internationality, because the international recognition of the service issued by accredited laboratories allows companies to expand their business more easily or foreign market. The VAG refrigeration laboratory is a unique cutting-edge structure in Europe, boasting 7 accredited standards, 5 test rooms for performance, consumption, and noise, 750 tests for 15,000 hours per year, and we can test product according to the main standard recognized at the European level in the refrigeration sector. In this slide, we can see the main standard that we can test. The laboratory has 5 test rooms that we can see directly in the section of the REFRIGERANTS website dedicated of the VAG refrigeration laboratory. This is our site. Okay, the VAG refrigeration laboratory was designed and developed with Università Politecnica delle Marche and is a cutting-edge technological center, which is a unique facility in Europe for R&D in the refrigeration world. Okay, now I will explain each lab. We start with lab 1. It is a climatic chamber inside of which 3 high calorimeters are installed to test the efficiency of refrigeration monoblock. Here we can carry out performance, energy consumption, and efficiency measurement according to the new standard PREN 17432 for air or water cooled system. In this lab, we can check the cooling capacity with the ambient temperature ranging from 0 to 55 degrees and with cold room temperature down to minus 40 degrees. Lab 2. Okay. It is a large calorimeter with a double cold room equipped with a cavity to eliminate heat loss toward the external environment. Here we test the performance and the efficiency of the forced convection air-cooled evaporator for refrigeration. We can measure cooling capacities from 200 watt up to 60 kilowatt with extremely light accuracy and repeatability of the data. In this lab, we test also the fluid dynamic efficiency of thermostatic valves and fluid control system. Finally, if necessary, lab 2 can be transformed into a climatic chamber for test on a refrigeration system by simulating external temperatures from 40 degrees down to minus 30 degrees. As regards lab 3, it is a climatic chamber equipped with 8 calorimeters. We measure the performance and efficiency of the compressor and condensing unit for refrigeration. We verify also the necessary data for declaration of conformity to ECODESIGN regulation. Here we can create a climatic environment between -15 degree and 55 degree. Condensing unit can be tested with a cooling capacity range between 300 watt and 100 kilowatt. In Lab 3, it is also possible to perform tests on air-conditioned liquid chiller, heat pumps, and the chiller for process cycle. Lab 3 has been designed and built to safely perform tests on CO2 and hydrocarbon system. Therefore, it has evacuation system controlled by very high resolution sensor, which allow any risk to be instantly eliminated in the event of very minor leak of CO2 or hydrocarbons. Okay, Lab 4. This is a semi-anechoic chamber. It is specifically designed and built to perform noise and vibration tests on any product, but with particular attention to the acoustic and environment analysis for refrigeration system. This system allows condensing unit to be connected to external calorimeters to reproduce any cooling load and any operating condition. The semi-anechoic chamber is also air conditioned. This way, it is possible to reproduce any cooling load and external environment condition. So we can simulate even extreme operating condition. Acoustic and vibrometric data can be acquired and measured simultaneously with machine performance and operating data. In this way, we can associate every acoustic phenomenon with a specific operating condition. Lab 4 allows tests to be performed according to EN ISO 3744 and EN ISO 3745. And finally, Lab 5. It is a climatic chamber built specifically for necessary energy efficiency test for verifying compliance with the ECODESIGN regulation and the declaration of energy class relating to domestic, commercial, and professional refrigeration. The chamber is equipped with a horizontal laminar flow ventilation system that guarantees an high speed between 0.1 and 0.2 meter per second at every point, and it has a stability control that guarantees chamber stability of plus minus 0.2 degrees and plus minus 0.3% of relative humidity. In particular, tests can be performed in compliance with the following standard. Refrigerated cabinet to display in the self-staff, refrigerated storage cabinet and counter for professional use, blast chiller and freezer cabinet for professional use, household refrigerating appliances, ice cream freezer, commercial beverage coolers, and vending machine. Okay, let's go to presentation. We are aware that this laboratory, in addition to testing our product and those of our customer, we have the ability to archive and analyze a mass of technical data that we use for certification and accreditation for our customer and for Revocol product and prototype development, and for collaboration with institutions and universities. Our main steps are collect and archive available data, define test plan with effectiveness, and support the development of solution and know-how. Our goal is to transform this amount of data into know-how to better understand the complex phenomena and develop more and more performing and reliable product. This is already the starting point for designing better Revocol solution for us and for the entire refrigeration industry to take an important step forward in terms of efficiency, technology, and environmental sustainability. We already did it, for example, in the development of our new BEST, a packaged system which, together with the other stationary and mobile refrigeration product, allow the Rivacol catalog a range of up to -40 degrees for our standard product. Therefore, in collaboration with our partner, we can test solution up to -80 degrees. This way, we can cover all the need of cold chain, both in the medical sector and in all other areas of commercial and industrial refrigeration. Thank you. That's all.
Thank you so much, Filippo. It was very nice. I think research and development is vital now because we have so many specialties, so many sectors to cover. So
yes,
we need research. We need research. This is for sure. So Silvia, do we have any question, please?
Yes, we have a couple from Raffaele. He
Yes,
is
please.
asking. Yes, so he is asking which is the for the lab 1, which is the maximum cooling capacity, and could it be compliant to test the rooftop devices until 40 kilowatts? So this is the first part of the question. And then the second part is any possibility to measure airflow rate and how?
yes, okay. In the lab 1, we can test the system up to more or less 30 kilowatt of condensing performance. For the second question, we can measure, and we measure at more or less all test the airflow. Yes, we measure the airflow at the condensing fan and at the evaporator fan.
We got another question also from Stephanie.
Yes,
she's
please.
asking how Rivacol can test refrigerant for vaccine cold chain at -70 degrees Celsius.
No, Rivacol don't test the vaccine. We do research and development for test the system that can measure temperature.
No, she's asking can test the refrigerant. She's asking how can it test refrigerant for vaccine cold chain that goes at -70.
Rivacol don't product this type of refrigerator, but in the bag refrigeration laboratory, we can test a system up to -70 degrees. Yes. For our
Have you done it already in this period, which is a busy period? Have you tested any -70 freezer at the moment?
But Rivacol don't product this type of refrigerator. But if our customer asks us a test with the specification of a laboratory for measure this temperature, the bag refrigeration laboratory can test this type of the tank.
Very good, Filippo. Thank you very much. It was very interesting. So let's go. Thank you, Filippo. I see you in a bit, right, for the discussion. So we have, last but not least, we have Antonio Sepe. We have still 120 participants to our conference. All the way through, we had a very high number of participants. So thank you to all our participants. We had a top of 140, I think. Now we are on 120. So it's very consistent and very balanced. So Antonio Sepe, I can see you, I can hear you. Thank you. Is talking about the latest technology.
Thank you very much, Marco. Thank you, Centro Studi Galileo, for this good opportunity to speak about Castel. Good afternoon, everybody. My name is Antonio Sepe. I am application manager for Castel. Today, I would like to show you the new products compatible with the new refrigerants, HFO and hydrocarbon. Here, our summary. Short remind about HFC phase down and deadline, about our products Polyhedra, application of Directive 2014, family products, and conclusions. Here, the current European F-gas regulation has the goals to cut F-gas emissions within 2013. The regulation of F-gas limits also the sales of F-gases And if there are some alternative, we can use these. Here, for example, deadlines. The new GWP limits is 2,500, and how you can read, we have a lot of opportunity. We have CO2, we have ammonia, we have hydrocarbons, and we have also some HFO refrigerants. It's most important, remember who spoke before of me, that more of these new refrigerant HFO are flammable. It will be most important to consider these if you compare to conventional refrigerants. Here, some example. For example, in air conditioning system, usually people can replace 410 versus 32 or 452B, 454B. But how you can read these new refrigerants HFO are A2L Ashar group. Now, the question is which kind of products we can install. The products, sorry. Okay, sorry. The products for new refrigerants, HFO blends, and also for hydrocarbon must be compatible with these new refrigerants. The materials like gasket and O-rings must be compatible with the new refrigerants. Need also declaration of conformity in according to Directive 2014 if we are speaking about category 1, 2, and 4, or manufacturer declaration if we are speaking about products Article 4.3 in according Directive 2014. Castel, what we done? Introduced a new range, polyhedra range, suitable for all refrigerant HFO and HFO blends, and also for hydrocarbons. Here you can read some example, not only refrigerants YF, ZE, 448, 449, but also the new 454B, 454C, and so on. Also hydrocarbons, and also classic conventional refrigerants like HFC. Most important, remember that in according Directive 2014, if the products has a nominal size below or equal to 25, you need manufacturer declaration. For 12U, we can consider all valves with connections from a quarter to 1.18 inch. Another important to know, nominal size, if products has a nominal size DN higher than 25, in this case we are speaking about valves with connections from 1.3/8 inch, you need a declaration of conformity. Here an example about our solenoid valves. If you compare the classic conventional products, Castel introduced a new label where you can read the part numbers and also the batch. This batch is most important because you will find also in declaration of conformity. This kind of declaration of conformity you will find inside of the box. If you need a copy, by our website, you can download copy declaration of conformity if you have part numbers and batch numbers. For classic products with nominal size below 25, we stamp the letter N on the body and we give manufacturer declarations. This is most important for to compare classic products and for to look if this kind of products is available for new refrigerant HFO or classic conventional refrigerants HFC. Another important question is about filters. Internal volume below 1 liters need for filters manufacturer declarations. For filters with internal volume higher than 1 liter, we need the declaration of conformity. Here you can see an example, declaration of conformity for interchangeable core for filters, and the batch number we stamp on new label, and also in this case the batch number you will find in declaration of conformity. Also in this case, declaration of conformity will be inside of the box. In the end, other important benefit about polyether products is the large pressure and temperature range. How you know most of these new refrigerants are using for heating pump for high pressure, more than conventional 45 bars, and for high temperature. Here you can read now the polyether products Castel has a new pressure, maximum pressure works 50 bars, and the maximum temperature range plus 150 minus 40. You can also install the new range polyedra inside the system that still use HFC refrigerants or for maintenance of the old system. What we can suggest, these new products for all refrigerants, new, and also if you still not decide which kind of refrigerant for you want to use or for retrofit, you can these products guarantee long-term, long life for your system. Here in this table you can read the family products, solenoid valves, safety valves, check valves, liquid indicators, and so on. We have, how I said before, manufacturer declaration for example, solenoid valves, check valves, and so on, with connections a quarter to 1.18 inch, and declaration of conformity for higher connections. So in the end, how you know the HFC consumption will be reduced by 79% within 2030 in Europe. Natural refrigerant like CO2 and hydrocarbon, we didn't speak, but I would like to remember also that Castel has a large range about also CO2, and HFO with low GWP are considered a good solution for long terms in refrigeration and air conditioning systems. We need only to use the appropriate refrigerant for each application. We don't have only one refrigerant for everything, but different solution for different systems. So in Castel introduced the new range polyedra, suitable for new refrigerant, hydrocarbons, HFO, and also HFO blends, classified A1, A2L, and A3 safety groups, compatible of materials, also large range and large temperature and pressure. The maximum pressure is now 50 bars, and the temperature minus 40 plus 150. Declaration of conformity for products category 1, 2, and 4. Manufacturer declaration for products article 4.3, and one product for any refrigerants, and also for maintenance of the system, for retrofit and old refrigerant, conventional refrigerants, HFC. This is a short presentation. Thank you for your attention. If you have a question, we have.
Thank you, Antonio. Thank you. We have one question. Was very informative with your components, and it's important to know that we can trust Castel for valves, components, for A2L and A3 refrigerants. This is very important. So Silvia, what we have?
So the question is from Luca, and it sounds very interesting because he is asking, how did you test your parts and your components to check that they have a tightness control level of less than 3 grams per annum?
Consider that Castel, we have in our production a lot of products lined with, in the end, helium test. In this case, we can guarantee on request 3 grams per year for solenoid valves, check valves, ball valves, and solo filters, and so on. Because, how I can repeat, we have in the end of line helium test completely automatically. And we have tested, we have setting our production for these 3 grams per year.
It's very important. So you can set your system as hermetically sealed, yes, which is important for F-gas regulation, and it will be even more important in the future to be labeled hermetically sealed system.
Sure.
Okay, I think there are no more questions for Antonio. I think we can call all the speakers together here with us now. If you want to turn on your camera, we have a final debate all together. I think you can see my slides yes, now with the webinar agenda. We had a long day. We are 10 minutes delay. We were supposed 15 minutes delay. We were supposed to leave to finish at 4:30. We are 4:45. Sorry for that, 15 minutes late. We have some questions for you for the debate, and I invite the audience to put more questions if they want to. I can read one question in particular for Ernesto, wasn't here earlier. In particular, maybe some other speaker can also answer. Jean-Francois says that in France, currently is not allowed A2L inside supermarkets. So he's asking why to compare with A3. I'm not sure. Do you think it's true that in France is not allowed A2L in supermarkets? I was not aware about this from my side. I don't know.
Well,
if you have
it
other.
Should maybe specify which kind of supermarket, because we are running some tests even in France with A2Ls, even for commercial refrigeration. We know that we need to carry out a risk assessment for sure to be compliant with the EN 378, with the charge limits, but I'm not aware about any restriction on A2Ls in supermarkets in France, actually.
Okay. So anybody else want to answer to this one? Have other information about France? I don't think, to be honest, is not allowed A2L, because it should be probably a big problem about if it's not allowed A2L in France. Okay, another question is more for everyone. Is Babak asking the importance of electricity, and Babak is from a developing country. So he's asking, in my country, electricity is mainly generated by fossil fuel. We use CO2 as refrigerant, but he thinks that increase the indirect emission due to the low efficiency of CO2 refrigeration system. Is CO2 a good recommendation in developing countries? I know EFTA has got some systems in developing countries. I think in
yes.
Do you want to say anything?
We have in Emirates, we have in Africa, we have in Australia, we have systems running in summer with 52 to 55 degrees. And I can assure that it was a problem in the past, but nowadays there is no efficiency loss at warm climates, because there are solutions that keep the cooling, refrigeration cooling capacity available unchanged even at the warmest climates. As I have presented before, there are specific solutions to do that, and also very simple, because when we are talking about emerging markets, of course, one of the difficulties we face is, of course, training and knowledge management. So on one side, we have to provide training. On the other side, we have to develop simple solutions that can be used anywhere without any barriers or barriers of concern. So the solution I have presented before, so extreme temperature efficiency by EPTA, for example, is doable and usable at any climate temperature without any loss of cooling capacity nor any loss of efficiency. So it's an ideal solution anywhere, and anywhere is a sustainable solution.
Of course, for a new system, of course.
Yes, for a new system, yes.
Okay, so I have one more question for, I don't know if anybody else want to say a few words about this, this question from Babak, because it is a general question about energy efficiency, of course. If not, I have a question for Rodolfo. From Luve. The temperature glide can be an advantage in heat exchanger in some cases.
Yeah, it really depends. So we have seen from my presentation that it really depends on what we consider as evaporating temperature, and if we consider the dew point rather than the mean point. So when comparing efficiency and of refrigerants, we have to consider we should consider similar working condition. So the benefit that we could have in working with a refrigerant with high temperature glide, if we use the dew point for calculation or to run the unit, it's not due to the fact that the refrigerant is a better refrigerant, but it's due to the fact that the new working conditions are different from what they were with the refrigerant with no glide. So it can be an advantage, but it's like a fake advantage, because we are just working in different conditions, and these different conditions can be a problem. For example, in a cold room, we could have the same dew point as a unit working with R404, so a refrigerant with no glide at a dew point, but we will have at the beginning of the evaporation process a much lower temperature, meaning lower surface temperature, meaning that the dehumidification effect we will have on the cold room will be much higher. So again, we can have a boost in efficiency, but we will have a different condition in the cold room at the end of the day, and this can impact the products that are stored in the cold room.
Okay.
So it can be an advantage, but we have to consider that it's not an advantage. It is just that the unit is working in different condition, and in different condition, meaning that we have a much lower temperature at the end of the day at the outlet of the air cooler. So
yes, yeah, I think we can take one question still for everyone if they want to answer. Please put in the chat box, and then we have to close because we are a bit late. One question from Bassam. We have still 100 person listening to us, so we are in a good company, and we do something interesting to our audience. So Bassam is asking, what are the recommendations for low GOP refrigerant in refrigeration in fishing vessels? I was witness myself, Marco, that in fishing vessels, you have so much leakage of refrigerant that normally fishing vessels, they have a cylinder connected to the refrigerant circuit, and they charge the refrigerant while they are working the fishing vessel. So it's important, this sector, even if it is not included in the gas regulation, unfortunately, because we know that the ships are not included. So do you want to suggest something? Maybe Miriam or Ernesto or someone or Stefano want to suggest something for fishing vessel and so ship? What is the right refrigerant? Used to be R22, of course, in the past. Now it's no more. What do you suggest?
But if I can say something, first of all, Stefano, I would say that we have to limit the leaks. First of all,
I agree with that.
You know, we have to check the leaks. So
okay.
This is the first impression I have. Yes, but basically it's better to check if we could have ignition, let's say, sources of very hot surfaces in the neighborhood of the leaks, because the HUL can be flammable in some particular condition, let's say. So this is the danger that I can see in this kind of situations. So yes, we have to check. I would like also to answer to the previous question that was about the glide, because yes. I would like only to say that we are working very hard on this matter, and very soon we will produce videos, webcast, let's say, explaining how to manage the glide, because it's very important. Thank you, Rodolfo, for your explanations, because it was very, very, very clear. I appreciated it very much. So being able to work in the mid point, it's very important, but we will also help the market and all the refrigeration engineers to understand better this important matter.
Okay, I agree with you about fishing vessel to check the leaks, but it's very difficult in this kind of small fishing vessel with fishermen to check leakages. And I can see, for example, in cars, which is not the same sector, of course, but also in cars, you know that leakages are very frequent. You know that. You know, you work in cars, Stefano. You work, and also Sergio. You work in cars, so you know that leakages are very frequent. Even in the manual of cars, you have, you have to check your charge every 2-3 years because it's very frequent. Do you think we can use HFOs in fishing vessels, in your opinion, Stefano or Ernesto? We can use HFOs, or is a direct replacement in fishing vessels? Do you have applications? No, not yet. You don't see any application yet.
Not at the moment, if I can say, but of course, 454C, for example, could be one of the possible refrigerants in order to substitute old HFCs refrigerants, for example. It works well with the low temperature, so it should be conducted a risk assessment of the system, of course, of the fishing vessel, where the system is, as Stefano was saying, so checking the possible ATEX conditions inside the vessels, but I think this could be a possible option for vessels, for example.
Okay. Last question for all of you is Mark from Canada, from the Association of Canada, our good friend. He's asking, Europe is ahead, is moving. In Canada and North America, we are hopefully, manufacturers will move swiftly to natural refrigerant and diminish the use of HFC equipment. Do participants see North America as a challenging market? Are your company working with North America to move to alternative refrigerants? I think all of your companies are working in North America. What are your expectations for North America? And I think with this last question, then we can end the webinar. So who wants to start with North America?
Well, I can start if that's okay with.
Okay, Rodolfo, please.
Yes. So I just want to say that yes, of course, Luve Group is willing and is addressing the American market. That it is probably the biggest market out there for a company like Luve that deals with the heat exchangers. We have seen in the last year some very big changes in the market, meaning that we have the Department of Energy in the United States ruling on efficiency on components that it was something not addressed till now in the United States. So we have seen this increase on attention on the efficiency of the systems and on the quality in general of the ratings of the units. Regarding the switch to standard fluorinated greenhouse gases to natural refrigerants, or in general to something more environmental friendly, let's call them this way, we know that there are some states that are ahead of the standard federal rules. One example is California, and other examples are some of the states on the East Coast. I've read yesterday on, I cannot recall what paper was, but it was a paper regarding refrigeration, that California has recently ruled on the fact that in supermarket some refrigerants with high GWP cannot be used from the year 2022. So this is clearly in a good news for CO2. And yes, I guess that the mentality of that market is changing, and is changing rapidly. So I
Thank
think
you,
that
Rodolfo,
in
for your
2 to 3 years that will be like we are now.
Okay.
Yeah.
I think more, to be honest. I think more than 2 to 3 years. I think maybe 5 to 10 years in North America.
Yeah, maybe in commercial
Francesco?
refrigeration it will be quicker, but yes, I agree with you. In some
Francesco?
other business it will be longer.
No, I'm pretty optimistic, because after the election of Joe Biden, his first statements were very much in favor of policies to protect and to fight the climate change. He wants to rejoin the Paris Agreement that was abandoned by Trump before, and he wants to take the lead on these climate issues, and especially, let's say, also he has the plan of 100 days. The first 100 days, he is going to rejoin the Paris Agreement and create a cross-functional new agency special for the research of innovative solutions in favor of the environment and to fight climate warming, the ARPA-C new agency, which will have one of the main focuses will be exactly on refrigerants used in refrigeration and air conditioning. So I believe that his first words are very, very positive, and we can be optimistic that he's going to take action and take the lead on that, and let's say reverse the policy of Trump, which was absolutely, let's say, ignoring the problem of this greenhouse gas emissions issue. So I believe we can be optimistic.
Very good. Yeah. So 2 to 3 years, 5 years maximum.
We can't say between words and actions what will be the time, depending also on his strength in the Senate and the possibilities he will have to do what he promises. But let's say the promises are very good.
The Kigali Amendments for North America, so also they should be following the Kigali Amendments if they sign the Kigali Amendments, of course. The US is far from signing the Kigali Amendments at the moment.
He's really taking the Green Deal, the European Green Deal, as a reference for his future policies. So he's a little bit copying our Green Deal.
Let's hope so. Let's hope so. Okay, anybody else? Do you want to say anything about the North American market?
Just a brief comment, since you know as I can speak as a first person, since my company is based in the US. From the top management in the US, there's a very strong focus put on the European F-gas regulation and what is happening on the European market in order to predict what will happen in the US in the next years. But there's a very strong focus on Europe right now. even from our base in the US. So this will happen for sure, even in the US. Probably now with the new election, it will be accelerated, and we hope so.
Very good. Okay, Karel and Castel, do you want to say anything about North America? I know that both Castel and Karel has got offices in. Karel also has got a production line.
Yes. Yes, I agree with the others that it will be very interesting to see what will happen after Biden election. And it would be important that the US will be aligned with Europe. As I said in my presentation, now there are standards that promote some refrigerant instead of another one. For example, the UL 289 will facilitate the use of H2 refrigerants with respect to A3 refrigerants. And so if with the new government in US, they go in the same direction as Europe, I think that they will facilitate the market for all the companies.
Very good. And what about Castel, Antonio?
Sì, about Castel. Castel believe about USA market. Consider that we opened 2 years ago the new office, sales office in Miami, and also warehouse. And I can confirm that our turnover, our business interest about Castel is improving, increase, special for CO2 products, honestly. About HFO products, still not, maybe next future, how the other people say it, maybe it will be interesting next future, but in USA and not also in Canada, we have interest, really interesting for CO2 products and for CO2 systems, sure.
Anybody else want to say a few comments?
Well, I want to say that despite the policy, the previous policy, which was not so much in favor of sustainable solutions and natural refrigerants in the US, some clients are very interested. And we also have a production in America. We do our refrigeration cabinets there, and we supply CO2 systems there. So there are clients which are interested. The interest is there, and we are selling CO2 systems there already. So we think that this is going to boost in the future, but this is already happening. So it's nothing really especially new in the US. It's something that is coming little by little already.
Very good, very good. Any comments about the seminar? Do you want to say a few words still? Okay, we can close the webinar. You can say, of course, hello to everyone. We can wish Merry Christmas and Happy New Year to everyone. We are at the end of the day of the year. We talked today about 2021. 2021 was the future for our sector. I hope the person that participated, the more than 200, if we include all the persons that participated today, enjoyed the webinar. I enjoyed. I personally enjoyed it. It's nice to have all our speakers here. So I thank all our speakers. I thank all our participants. I thank my group of Silvia and Alberto, of course. I thank for their hard work. And it's up to you now to say a few words. Rodolfo, Antonio, Stefano, Sergio, Silvia, Miriam, Francesco, and we can close afterwards.
Okay, I wish you all a Merry Christmas and a Happy New Year. That's thank you for attending this presentation, and hope to see you personally next year. Yeah, that's something I'm really looking forward to. I'm done.
Agree with Rodolfo. So we wish to see you all next year in conferences and fairs. And once again, thanks to all of our partners for the contributions, which always give excellent quality to our audience.
Thank you.
I'd like to say stay healthy and stay safe. And of course, you and your families. and Merry Christmas from our side. Thank you.
Thank you, everybody, and Merry Christmas and a happy 2021, hopefully better than 2020.
You can stay in Spanish, Miriam. Feliz
Feliz
Navidad.
Navidad y próspero año nuevo.
Bene, saluti a tutti allora.
Thank you.
Ciao,
Thank you.
ciao.
Bye bye.
Ciao, ciao.
Bye bye.